February 2026. Dense orbital maps filled with streams of data sprawled across the control room of the Solar System Research Center. Dozens of scientists stared at a nearly motionless dot on the screen, a dot with the official code name 3I divided by Atlas. But motionless was exactly what made it absurd. In celestial mechanics, nothing is ever truly motionless. Every object must obey the dance of gravity and inertia. Even a stone tossed from your hand follows a precise trajectory, pulled down by Earth or at the very least, slowed by air resistance. Yet 3I divided by Atlas, a massive block of ice and dust the size of an entire city, was spewing jets of gas into space without shifting in the way it should have shifted. Picture yourself standing on a skateboard, holding a spray bottle. Every time you squeeze the trigger, the water bursts out in a tiny stream, and your skateboard, obeying the law of momentum conservation, glides slightly in the opposite direction. That logic cannot be denied. Now imagine a mountain-sized object venting millions of liters of water vapor and carbon dioxide into the void like a colossal engine, and yet its path remains as smooth as if drawn by a steel ruler. No trembling, no lurch, no orbital disturbance showing up in the data. It was like watching a deflating balloon that, instead of darting wildly around the room, hovers calmly in place, defiantly mocking the laws of physics. This wasn't some minor laboratory anomaly. It was a direct slap across the face of planetary science itself. Engineers call this phenomenon the rocket effect. It has been proven thousands of times, from dust particles pushed by sunlight to the Rosetta spacecraft having to adjust its orbit around Comet 67P because of unexpected jets of vapor. Even the International Space Station must fire its small thrusters to counteract the faintest drag of Earth's upper atmosphere. Nothing can escape this principle. Except, it seemed, Atlas. Scientists described it with two parallel emotions, breathless awe and heart-tightening confusion. Awe, because this could be the first sign of a physical mechanism humanity had never even conceived. Confusion, because if the most basic laws could be shredded right before their eyes, what was the foundation that human knowledge truly stood upon? A young researcher at the James Webb Telescope exclaimed in an internal report, "It's like seeing a whale flying across the sky. You cannot believe it, yet your eyes record it." What heightened the suspense was the uncanny timing. Atlas was not drifting at the fringes of the solar system, where data is always murky. It was advancing into the vicinity of Mars, where a fleet of human probes was already active, from the Mars Reconnaissance Orbiter to the Perseverance rover. That meant every passing hour delivered gigabytes of fresh data from multiple vantage points, and all confirmed the same thing. The object was erupting violently, yet its orbit remained unnervingly stable, defying every prediction. The scientific community's curiosity ignited into a frenzy of data hunger unlike anything before. Observatories in Chile, Spain, and Arizona lined up for priority time just to capture a few more hours of Atlas's light. Each measurement was like straining to hear an unfamiliar instrument in the cosmic symphony. A sound was present, unmistakable, yet it refused to resonate by any known rule. The very gap between the expected data and the recorded data turned Atlas into a rebel object, rebelling not only against orbital models, but against the very sense of security that modern science had built. And then, when the detailed analyses were released internally, confusion transformed into an almost electric anticipation. Every plausible scenario began to collapse. If it were an ordinary comet, why was there no NGA, non-gravitational acceleration? If it were a dry, solid asteroid, why did it trail a blazing plume of gas stretching hundreds of thousands of kilometers? If it were a colossal body of immense mass, why did its brightness and density contradict each other? Three questions, three blades, tightening around the scientific community, as though the universe itself had set up a puzzle to test them. In those early days of 2026, the world suddenly felt it was witnessing a grand experiment, not confined to a laboratory, but unfolding across the scale of the solar system. 3I divided by Atlas was no longer just a dot against the heavens. It had become a mirror held up to humanity's own foundation of knowledge. People spoke of it with a tone that was half reverence, half enchantment. And deep inside every researcher, a burning question rose. Were they witnessing an extraordinarily rare natural phenomenon, or standing face to face with a technology that did not belong to Earth? In the days that followed, the atmosphere within the scientific community began to resemble a global courtroom. Evidence was presented, Rebuttals countered rebuttals, each new data point like a witness, yet a witness that refused to testify. Measurements from James Webb, Hubble, and ground-based observatories all agreed that Atlas was erupting violently, expelling colossal amounts of matter. But when teams calculated their trajectory using that very data, the results came out smooth, as though nothing at all had been acted upon it. In science, rarely is a paradox so stark, a cause so obvious, yet no visible effect. To explain it to the public, one scientist used a metaphor. Imagine a freight train kilometers long, pouring out thick clouds of smoke and steam from every vent. By all logic, that machine should shudder, jolt, or even have its wheels skid off the tracks. But instead, it glides as effortlessly as a magnetic monorail in a city. The discrepancy isn't a matter of a few percent, it's a chasm. This analogy spread rapidly across global headlines, transforming Atlas from an obscure designation into the epicenter of the world's curiosity. Unease began creeping even into the steadiest minds. Dynamicists, long accustomed to calculations precise down to milliseconds in satellite trajectories, now had to accept that a giant exception was mocking them. A former engineer who once worked on orbital corrections for Starlink admitted, "Just a few stray molecules in the upper atmosphere are enough to nudge a satellite off course. We burn fuel constantly to adjust. And yet Atlas can vent millions of tons of material without budging an inch." The contrast was like watching a child hoist a skyscraper with one hand, impossible, yet undeniably happening. The tension only mounted as Atlas drew closer to Mars. It was no longer a distant speck beyond reach. It was entering a zone where humanity's electronic eyes swarmed. Mars Odyssey, Mars Reconnaissance Orbiter, Perseverance, even aging, CubeSats still lingering from old missions. All at once, they became reluctant witnesses. Streams of data poured back to Earth without pause, and within every transmission, scientists hoped to find a crack, a tiny sign that Atlas would at last bow to Newton's laws. But day after day, the path remained unnervingly flawless. Curiosity spilled beyond the boundaries of science, erupting into a global thirst. Headlines screamed, "The object defying Newton, the stubbornest ice dust mass in the universe." Social media is flooded with millions of questions. Is this proof of extraterrestrials? Or are we just facing the edges of physics we don't yet understand? Public fascination heaped even more pressure onto researchers. They were no longer confronting a paradox in private. They were expected to deliver answers to a planet hanging on every update. Behind closed doors, some began to whisper bold hypotheses. Could there be a stabilizing mechanism actively cancelling every wobble? No one dared say it publicly. It risked sounding too much like engineered technology. Yet as each natural explanation collapsed, the idea germinated in secret, like a seed sprouting in the dark. A handful of internal reports compared Atlas to the ISS, which requires constant thruster burns to hold its orbit steady. The difference was stark. The ISS must spend fuel endlessly, while Atlas appeared to accomplish the same feat silently, invisibly, as if its entire structure had been programmed for perfect balance. Confusion soon tipped into suspense when spectroscopic readings revealed not only water and CO2, but traces of unusual metallic elements. Science couldn't yet confirm their significance, but each new fragment of data resembled a puzzle piece that didn't fit an alien shard in a 1,000-piece jigsaw. The more pieces they placed, the more the emerging image seemed incompatible with anything known. And beneath all the tension, a single question grew louder, echoing everywhere. If this is not merely a natural body, then what are we witnessing? The question had no answer, yet it crept into scientists' dreams, filled nightly broadcasts, and reverberated through the imagination of millions. Atlas had already transcended the role of an icy dust mass. It had become a new yardstick for humanity's curiosity and for its deepest anxieties. March 2026. Atlas had become the lead actor on the cosmic stage, and every passing hour felt like a performance the entire world watched with bated breath. No longer confined to the realm of astronomy research, it spilled out of laboratories and journals, onto the front pages of newspapers, into nightly newscasts, and even into everyday conversations. People spoke of Atlas while sipping morning coffee, while dropping their kids off at school, while re-watching the grainy footage of the moon landing. And in every conversation, a shared emotion emerged, awe at the strangeness, coupled with a shiver of unease at not knowing what was truly unfolding. On the scientific front, observation teams were working nearly around the clock. The Rubin Observatory in Chile, barely a year into operation, was pushed to its limits, using its wide-field camera to scan every corner of the sky around Atlas. James Webb, stationed far out at L2, sent back infrared spectra so detailed that scientists spent weeks just parsing them. Every line of data, every stray photon from Atlas was cross-checked hundreds of times. And still, the tension only mounted. Everything confirmed. Atlas was venting continuously, and yet there was absolutely no sign of orbital deviation. A researcher wrote in an internal report, "If you saw a volcano erupting violently, you would expect the ground around it to tremble, to fracture, and the lava flows to push massive slabs of rock aside. But in this case, the volcano erupts while the ground beneath it remains eerily solid. It defies logic." The analogy was shared across forums, leaving the public both more astonished and more unsettled. Confusion gave way to suspense as new hypotheses surfaced. Some teams calculated that perhaps Atlas was enormously massive, far larger than first estimates, comparable to a mountain of solid rock. In that case, its immense inertia could absorb the recoil of its escaping gases. But almost immediately, others countered. If it were that heavy, why was its brightness so faint compared to other bodies of similar size? Scientific papers poured out in rapid succession, stacking up like bricks, but instead of building a house of reason, they constructed a labyrinth where every corridor ended in a dead end. Curiosity spread far beyond research circles. International astrophysics conferences swelled with unprecedented crowds, live-stream tickets selling out within minutes. Discussions about Atlas streamed online to millions of viewers, where scientists fielded raw, unnerving questions live. If Newton was wrong, then what else can we trust? If Atlas is a machine, who built it? Are we being watched? The more questions arose, the faster hearts pounded, turning suspense into a global experience. Strangely enough, the more data arrived, the sharper the paradox became. Updated orbital maps displayed Atlas's trajectory as a razor-thin steel line cutting through space, unyielding against every imagined nudge. Meanwhile, images from Hubble and Rubin revealed a colossal cloud of dust, shimmering like a storm of light surrounding it. Two realities coexisted. One vision of explosive chaos, the other of absolute stability. Humanity was trapped in the void between those two portraits, and in that void, the fog of bewilderment grew thicker. Inside control rooms, new tests were proposed almost daily. One team suggested comparing Mars orbit data with Earth orbit data to detect even the tiniest deviation. Another proposed bouncing low-frequency radar from Earth to tap Atlas, hoping the returning signal might reveal its inner structure. Yet, even before experiments began, many had the same premonition. No matter the tool, Atlas would keep playing, hide and seek, leaving gaps in the results. That very premonition created a lingering suspense, the feeling of waiting for a secret you already know will not be revealed. In every news broadcast, anchors' voices grew heavier, their words resonating with tones both solemn and trembling. Atlas remains on course. The phrase echoed like a monotonous drumbeat, and yet with every repetition, it stirred fresh waves of curiosity. Ordinary citizens, people who had never heard of momentum, conservation, or non-gravitational acceleration, could sense something off about the universe they thought they understood. And so, Atlas was no longer just a celestial body. It had become a living paradox, a trial by fire for the limits of human knowledge. Like a vast mirror suspended in the heavens, it forced us to confront ourselves, to ask, is the knowledge we cling to truly enough to explain reality, or just a fragile mask waiting to tear the moment the universe decides to pose a harder riddle? April 2026. Atlas continued its relentless course, advancing deeper into the solar system's inner orbits, with a silence so suffocating it seemed to press down on every observer. After 3 months of continuous monitoring, the paradox should have begun to yield an explanation, but instead, it sharpened. The accumulation of data did not close the gap. It widened it into a vast abyss. Research teams had once hoped that, with enough time, they would spot a crack in its orbit or detect even the tiniest oscillation. But the results remained identical to those of the earliest days. Atlas erupted violently, yet maintained its balance as though the entire universe were holding it aloft in an invisible hand. The wonder of science had by now gone far beyond ordinary astonishment. It became something like an obsession. Scientists were no longer simply amazed, they were being drawn into a labyrinth of data. On many nights, the control room stayed lit until dawn, eyes bloodshot, Researchers reran models over and over, shifting variables, turning hypotheses inside out. Yet every calculation returned the same verdict: no significant non-gravitational acceleration. The repetition, instead of offering comfort, thickened the atmosphere with dread. Some journalists compared the phenomenon to listening to a grand symphony with the drumline missing. You can see the percussionist's mallet strike. You know the beat should thunder, but the sound never comes. That impossible silence, so present and undeniable, only deepened the suspense day by day, like waiting for a blow that never lands. Atlas also forced science to turn its gaze inward. At conferences, a phrase began surfacing more often: the limits of the model. Humanity had long trusted that Newton's laws, orbital mechanics, and even relativity itself were enough to explain the motion of any body. But Atlas acted like a mirror, reflecting our complacency at us. It didn't shatter the laws, but it bent them, reminding us that such laws are only approximations within a bounded range. Beyond that range, mechanisms may exist that we have not yet named. Curiosity bled into other disciplines. Particle physicists asked whether this might be the footprint of some unknown form of matter. Space weather specialists wondered if interstellar magnetic fields were interfering. Even philosophers joined the dialogue, framing Atlas as a symbol of human knowledge's finitude. The common thread running through all these speculations was unease, a tremor in the face of the possibility that the universe guards more layers of secrecy than we had ever imagined. For the public, Atlas quickly transcended science altogether. It became a story of the age, a new chapter in humanity's confrontation with infinity. On social media, people painted, composed music, and even produced short films inspired by it. Some called it the silent volcano. Others, the eye of the universe is watching us. Curiosity was no longer an individual reaction. It had become a collective experience. Across time zones, across cultures, humanity pulsed with the same burning question: what is Atlas, truly? The sweat dripping from researchers onto their keyboards mirrored the pounding of millions of hearts across the world. Everyone knew that time was not on their side. Atlas would pass by only once. It would continue its interstellar journey, and if humanity failed to grasp its secret within this narrow window, it might take thousands of years before such a chance returned. That urgency infused every bulletin, every update with breathless intensity, as though humanity were racing not against one another, but against the universe itself. And in that race, a new emotion bloomed: reverence. No longer just scientific awe or creeping confusion, but a reverence born from realizing the cosmos is far too vast, while humanity is so small, small enough to stand before a paradox it cannot untangle. Excitement, curiosity, dread, all converged into a spectrum of feeling that made Atlas not only an object of observation, but a psychological mirror for all of humankind. In the quietest hours of the night, as telescopes kept their cold lenses fixed on the heavens, scientists whispered to one another, "Perhaps we'll never explain Atlas, but maybe that's what makes it matter." And so the paradox, rather than a solvable equation, became a symbol of curiosity that never dries up, of suspense that never stops burning, and of the reminder that the journey of science has no true ending. May 2026. While state-of-the-art telescopes were locking their lenses onto Atlas in an attempt to decode the paradox of the rocket effect, a small group of scientists chose to turn their gaze backward in time. They combed through old archives of sky surveys from 2025, back when Atlas had no name, no notoriety, and had yet to step into the global spotlight. And in those faint, overlooked frames, a string of clues began to surface, sparking a wave of curiosity fiercer than any discovery to date. In a photograph taken by the Rubin Observatory in May 2025, Atlas was nothing more than a faint dot wedged among thousands of crowded stars. Nobody paid it any attention. It was like a speck of dust lost on the vast mirror of the cosmos. But when the more advanced processing software of 2026 was applied to reanalyze it, the dot suddenly stood out. It was shifting faster than the surrounding background objects. A tiny detail, almost trivial, but in astronomy, a displacement of just a few pixels can become the key to unlocking an entire new door. Curiosity swelled as the team scoured other frames. By July 2025, in another sector of the sky, Atlas reappeared, this time a little brighter, trailing behind it a faint, inexplicable streak. A comet's dust tail usually points away from the sun, yet this streak leaned in another direction, as if the material were being pulled backward. The first people to lay eyes on the image froze. A young astronomer gasped, "It looks like the wind is blowing the wrong way." That sense of bewilderment spread quickly across the room, because everyone knew there is no wind in space. So, what had shaped that counterintuitive streak of dust? A deeper unease set in when the group compared their findings with detailed star maps from the same period. Atlas had been moving through the region near Sagittarius, the galactic center, where stars crowd the sky like a sea of city lights. By theory, spotting an interstellar object from that direction should have been nearly impossible, the glare of billions of stars drowning out any lone wanderer, yet somehow Atlas had slipped through, leaving traces in at least 6 separate observational runs. The feeling of discovering that trail was like realizing a mysterious guest had walked across your front yard for months, leaving footprints you never noticed until long after. This revelation lit a fire in the public once the news leaked out. "Atlas was here all along, we just didn't notice," blared a major headline. Readers were instantly pulled in, captivated by the eerie scenario. Something enormous had entered the solar system, passed through the gaze of dozens of telescopes, and yet humanity had only belatedly recognized its presence. The unease deepened as scientists described Atlas's unusual brightening during its early days. After the first detection in July, its apparent magnitude increased at a rate far steeper than models predicted. Normally, as a comet nears the Sun, its surface ice sublimates, and the glow intensifies gradually, but Atlas's surge was far too abrupt. It was like watching a dim lamp suddenly crank to full brightness, dazzling the eye. The question hung in the air: did Atlas harbor a completely different mechanism of luminosity, or was something else hidden within that haze of dust and gas? Reanalyzed images from Hubble and Rubin revealed even stranger details. Alongside the anti-tail, that backward-facing streak later immortalized in astronomical papers, small bursts of light appeared and vanished, like sparks leaping from a giant ember. They refused to conform to the familiar geometry of cometary tails. Some even seemed to angle toward the Sun, directly against the force of the solar wind that should have swept them away. The astonishment was impossible to disguise. During a live-streamed conference, one researcher fell silent for several seconds while presenting the images, before blurting out, "We may be looking at behavior no comet has ever displayed." That single admission was clipped, shared, and circulated across scientific forums and public feeds alike, because if even a seasoned expert had to pause, had to concede bafflement, then the weight of the mystery could be felt by everyone watching. Curiosity, unease, astonishment, the 3 emotions, fused into a collective current. Atlas was no longer just a moving speck of light. It had become a living story, a narrative unfolding retroactively in every old frame rediscovered. And what drew people in even more was this: the pieces didn't fit. Each new scrap of evidence didn't complete the puzzle. It opened up new corridors, a maze where every turn led not to answers, but to deeper riddles. It was as though the universe itself had invited humanity into a guessing game, one whose rules we hadn't yet begun to understand. June 2026. As the old data gradually became public, curiosity rapidly turned into a worldwide frenzy. Scientific papers that once drew only the eyes of specialists now filled the front pages of mainstream newspapers. Every blurred image of Atlas from 2025 was scrutinized as though it were evidence in a courtroom drama. Circles were drawn around every faint speck, the lengths of dust streaks were compared, and motion sequences were reconstructed. And the conclusion, again and again, was the same. Atlas had behaved differently from the very first moment it appeared. Within the scientific community, curiosity erupted into heated debates. One faction argued that the unusual brightness and the anti-tail phenomenon were simply matters of perspective. When Earth, Atlas, and the Sun lined up on the same plane, dust particles ejected could create the illusion of a backward tail. But the opposing faction countered fiercely. An illusion cannot last for weeks and repeat itself across multiple observations. The tug-of-war grew so sharp it electrified the air. International conference halls transformed into scientific tribunals, where each team laid out its evidence under the scrutiny of hundreds of restless eyes. Unease mounted as more offbeat details emerged. Certain spectroscopic analyses revealed irregular oscillations in the light reflected from Atlas pulses like the beat of a heart, repeating at fixed intervals. Cautious scientists suggested this might be the signature of a rotating cometary nucleus. But to the public, the interpretation fled instantly into something far more dramatic. Atlas is sending signals. On social media, theories spread like wildfire. Some claimed it was cosmic Morse code. Others insisted Atlas was a disguised probe. Astonishment now came not only from data itself, but from the collective imagination exploding around it. Curiosity soon swelled into an unprecedented hunger for information. News networks broadcast live press conferences from NASA, ESA, and even China's space agency whenever an Atlas update dropped. Dry graphs of brightness, orbital plots, and spectral lines suddenly became familiar visuals to ordinary people. They followed each curve and digitized the way they would follow the heartbeat of a patient in critical care. One journalist quipped, "Atlas is now like a global movie star. Every flicker of its light sends millions holding their breath." Yet alongside curiosity, unease seeped into everyday life. In cities around the world, rumors circulated that Atlas could be a harbinger of cosmic catastrophe. Space agencies repeatedly reassured the public that there was no risk of impact with Earth, but the anxiety lingered. Apocalyptic scenarios spread across social platforms, racking up millions of shares. Artists illustrated visions of Atlas crashing down on the planet, haunting countless people with sleepless nights. What had begun as awe was morphing into a chilling sense of dread. The very object that inspired wonder from afar might also conceal unforeseen danger. Among researchers, astonishment was now palpable. Veteran scientists admitted they had never encountered an object that defied models so completely. They were used to hypotheses being wrong at first, but rarely did an entire theoretical framework fall into confusion. At a symposium, one senior professor remarked, "Atlas is like a model student who walks into class, only to answer in a completely foreign language when called upon." The audience laughed at the analogy, but the laughter trembled with unease. Everyone understood. If Atlas was truly speaking in another language, humanity was nearly blind to its message. Curiosity crested into a new wave as predictions for Atlas's future trajectory came into focus. By calculations, it would reach perihelion at the end of October 2026. That would be the moment its brightness and activity peaked. Astronomers called it the 0 hour, the decisive point to resolve the great questions. But the countdown also carried tension laced with anxiety. Because if, after everything, even at its brightest, Atlas refused to yield an explanation, then humanity would have to face the reality of standing before a mystery far beyond its comprehension. By that June, Atlas was no longer a nameless celestial body. It had become a mirror reflecting the psychology of an entire civilization. Endless curiosity, lurking unease, astonishment tinged with hope. Night after night, as new images streamed down from telescopes, millions across the globe lifted their gaze to the same sky and whispered the same thought. Were they witnessing an extraordinary comet or stepping into a brand new chapter of the universe itself? July 2026. Atlas had traveled nearly halfway to its perihelion. Each night, across the planet, dozens of telescopes aligned their lenses with its path. The latest images from the Rubin Observatory revealed Atlas now shining hundreds of times brighter than when it was first spotted. A vast halo of dust and gas enveloped it, casting pale, luminous veils across space. Yet strangely, within that brilliance, the sense of unease only grew stronger. For behind all that glitter still lay the same paradox unresolved, unyielding, a paradox that mocked the very foundation of human knowledge. At an international press conference, scientists projected a time-lapse sequence of Atlas from 2025 to the present. On the massive screen, the audience collectively held its breath as Atlas's orbit appeared. A cold, unwavering straight line, indifferent and immovable. Yet right alongside it, the images showed plumes of dust erupting violently, changing shape from week to week, even day to day. The juxtaposition was staggering. One journalist described it as standing before a volcano in full eruption while the ground beneath your feet remains perfectly still. The world shared in the shock because ordinary logic no longer applied, and the impossible was unfolding openly before their eyes. Curiosity surged to its peak when the anti-tail phenomenon returned in vivid clarity. Dust streams, instead of trailing away like any ordinary comet, fanned outward in the opposite direction, like arrows of light aimed directly at the sunday. Experts attempted to explain it away as a trick of perspective, but three-dimensional reconstructions from multiple observatories confirmed the effect. Too clear, too long, too persistent. For the first time, the word anomaly felt inadequate. Scientific papers began to adopt harsher phrases. outside models, unclassifiable, behavior without precedent. The public, meanwhile, exploded with imagination. Special television broadcasts aired with titles like Atlas, the Challenger of Newton. On online forums, millions spun their own theories. Atlas might be the relic of a vanished civilization, a colossal structure eroded over millions of years, or even a cosmic eye staring back at us. Curiosity no longer meant merely seeking truth. It had become a fever of collective creativity, with human imagination rushing to fill the silence science had not yet broken. But alongside the wonder simmered a quiet dread, as though humanity were knocking on a door without knowing what waited on the other side. A fresh wave of astonishment swept through when James Webb transmitted the most detailed spectrum of Atlas to date. Strange absorption lines appeared, hinting at compounds never before detected in any comet of the solar system. Laboratories around the world scrambled to compare the data, but no clear explanations surfaced. Some scientists admitted bluntly, "We do not know what we're looking at." In that moment, curiosity erupted into collective restlessness, as though humanity stood before an open book, staring at characters it could see but not decipher. On global media, conflicting emotions twisted together: curiosity and fear, hope and anxiety. Some outlets described Atlas as the universe's colossal mirror, reflecting humanity's fragile grasp of reality. Philosophical commentators went further, declaring that Atlas was a reminder that every civilization must eventually face its trial, the moment when truths once thought unshakable suddenly tremble. For them, Atlas was not just an object, but a psychological test for humankind. Across society, unease manifested in countless ways. Online communities began selling survival kits in case Atlas carried hidden threats. Spiritual groups proclaimed it a sign of impending transformation for humanity. Children doodled Atlas in notebooks, imagining it as a fire dragon, a god, or a colossal machine. Curiosity, unease, and astonishment braided together into a cultural phenomenon that reached far beyond the boundaries of science. Atlas was no longer just a subject of research. It had become a symbol. That July, under summer skies scattered with stars, millions in both hemispheres tilted their heads upward, searching for Atlas's faint streak among the constellations. And in every gaze, the same question echoed: were we witnessing a chapter of astronomical history, or brushing against a deeper mystery about humanity's place in the universe itself? In planetary science, non-gravitational acceleration, NGA, is regarded as the secret language of comets. Whenever an icy nucleus approaches the Sun, its frozen interior begins to sublimate, producing jets of gas that erupt into space. These outflows, no matter how faint, generate thrust. Much like squeezing the nozzle of a balloon sends it darting in the opposite direction. A comet's orbit shifts ever so slightly, leaving a distinct signature in observational data. NGA has thus become a delicate tool, allowing scientists to listen to the heartbeat of a celestial body. Over the past decades, nearly every comet studied has carried clear NGA signatures. A classic example is Comet 67P, divided by Churyumov-Gerasimenko, where the Rosetta spacecraft once landed. Data from Rosetta reveal that even a few jets escaping from tiny surface cracks were enough to force the spacecraft to adjust its orbit constantly. The orbital drift of 67P was small, just a few millionths of an astronomical unit per day, but it was sufficient for scientists to chart a detailed map of its activity. In other words, NGA is the heartbeat every comet possesses, faint but steady, impossible to fake. Even interstellar visitors that have passed through our solar system bear the same familiar trace. The most famous case was Oumuamua in 2017. Though no obvious dust-tail was observed, its trajectory still showed a slight deviation, forcing scientists to debate the presence of unseen outgassing. Another case was Comet Borisov in 2019, which behaved in perfect textbook fashion. It erupted violently, shifted its orbit exactly as expected, and became a reference model for comparison. With such a foundation, scientists entered 2026, confident that Atlas, an interstellar object, dazzlingly bright and violently active, would follow the same rulebook. Some research teams even prepared computer simulations ahead of time, predicting orbital shifts based on Atlas's brightness and apparent outgassing. Graphs were drawn with pre-plotted NGA curves. Internal reports predicted, with certainty, that clear signals will soon be detected. Yet when the first measurements were conducted in June and July, the anticipated heartbeat never arrived. Scientists searched for even the faintest sign of NGA, listening as though through a stethoscope pressed to the chest of the cosmos. They cross-checked data from the Rubin Observatory in South America, the James Webb Telescope at L2, and radio observatories in West Virginia. But instead of detecting irregular rhythms, every instrument returned the same cold verdict: no non-gravitational acceleration. At first, confusion lingered quietly, tempered by caution. Perhaps the data span was too short. Perhaps stellar background noise had drowned out the signal. Perhaps the processing software required further refinement. But as the weeks stretched into months, and terabytes of new observations continued to flood in without a single trace of NGA, the unease solidified like a tumor forming at the heart of the research community. One scientist wrote in a report, "We are waiting to hear the heartbeat, but Atlas is silent, and this silence is more terrifying than any irregular pulse could be." From what should have been a straightforward physical phenomenon, NGA had turned into a locked door, forcing humanity to question the very laws it once trusted implicitly. Against this backdrop, the early stage of curiosity gave way to something more complex: scientific bewilderment. Nobody understood how an object erupting so violently could maintain a trajectory as straight as if guided by an unseen hand. And from that point forward, fierce debates erupted, debates that would shape the chapters still to come. August 2026. Atlas was drawing closer to Mars's orbit, and telescopes across the globe worked tirelessly. Every hour, new orbital data was downloaded, analyzed, and released to the research community. Yet instead of bringing satisfaction, the numbers only tightened the sense of suffocation. All they showed was a pristine trajectory, no tremors, no oscillations, a cold, unbroken line carved into space. Meanwhile, images of Atlas revealed violent eruptions, pillars of dust and gas stretching hundreds of thousands of kilometers. The contrast was not merely puzzling, it felt like a cruel joke played by the universe. Research teams began publishing detailed reports. A German group compared Rubin Observatory's data with orbital models that included NGA. By their estimates, the expected deviation should have equaled the distance between two telecommunications satellites. In reality, the measured offset was virtually zero. A Japanese team employed light analysis to estimate gas venting speeds, calculating that CO2 emissions alone should have nudged Atlas several kilometers off track each day. But when they compared their findings with orbital data, the results aligned perfectly with pure gravitational predictions. No errors, no shifts, no trace of non-gravitational acceleration. The mood at scientific conferences grew tense. Presenters often stumbled mid-speech, as hands shot up the moment results appeared on screen. Some insisted the instruments must have malfunctioned. Others suspected overlooked variables in the calculations. One American scientist snapped, "If our data shows Atlas has no NGA, it means we don't yet know how to measure it." But the opposing side countered sharply. NGA is not optional. It is the inevitable consequence of Newton's laws. If we can't detect it, that means Atlas is challenging the law itself. The statement dropped like a stone, leaving the hall in heavy silence. Debate stretched on, taut as a fraying wire. Online forums, filled with endless analyses, graphs, formulas, orbital diagrams. Many younger researchers confessed they had never felt such helplessness. They were used to hunting down errors and eventually closing the gap with a reasonable conclusion. But this time, no errors remained. Every dataset was consistent, and it was that very consistency that became the nightmare. Doubts began to seep outward, spilling into the public sphere. Some journalists published headlines claiming Atlas may be controlled by an invisible mechanism, and the stories spread like wildfire. Although mainstream scientists avoided terms like artificial or technology, their silence only fueled speculation. One commentator observed, "People usually fear unpredictable anomalies, but what's far more terrifying is when every piece of data is flawless in a way that should be impossible." For those inside the field, the bewilderment became visceral during nightly observations. They described Atlas as a patient coughing violently, yet when the stethoscope was placed to its chest, the heart and lungs remained perfectly silent. This silence was not normal, it was a paradoxical void, and the longer they stared into that void, the more it felt like confronting a bottomless abyss within their own understanding. September 2026. The closer Atlas drew to perihelion, the deeper the fractures within the scientific community became. Conferences that once carried an air of solemnity now resembled battlegrounds, where each side wielded data as weapons, and every rebuttal cut like a blade. No one denied that Atlas was erupting violently. That was the one point of consensus. But from that consensus, two opposing camps emerged. The first camp believed the fault lay with humanity. They argued that measurements, no matter how advanced, could still be plagued by interference. A seasoned researcher emphasized, "What we call NGA silence may simply be an illusion born from instrument limits." Remember, Oumuamua baffled us too, but in the end we arrived at a reasonable explanation grounded in conventional physics. To them, science had never failed, there was only the matter of incomplete data. The second camp, however, insisted that the absolute absence of NGA could not be dismissed as a technical glitch. They pointed to Atlas's flawless orbital curves, stressing that independent teams, using different instruments across different nations, had produced identical results. "This is not a system error," declared a young dynamicist from Europe. "This is a real phenomenon, and if we refuse to confront it, we will remain lost." Tension hung heavy in the air during discussions. At times, silence stretched for minutes, broken only by the hum of projectors, because no one dared speak the thought all shared, that perhaps Atlas was being controlled by a mechanism science could not yet describe. The doubts no longer stopped at questions of data accuracy, they began to pierce the bedrock of assumptions. Some scientists whispered that perhaps we had grown too confident in Newton's laws when applied to interstellar objects. Could the interstellar medium contain forces or fields unknown to us? Could Atlas, in some inexplicable way, be revealing a chapter of physics still unwritten? That question sent chills through the community, stirring both dread and fascination. Division soon spread beyond academia and into the public sphere. On social media, people followed conferences like sporting events, casting votes for Team Faulty Instruments or Team New Phenomenon. Sensational headlines screamed across news outlets. Atlas silences Newton, science splits before an interstellar visitor. The pressure on researchers mounted. Those who chose to remain silent, avoiding public statements, only further fueled suspicion. At observatories during late-night watches, scientists felt the full weight of uncertainty. Some endured sleepless weeks, combing through datasets again and again, desperate to uncover a missing variable. Others sat for hours staring at Atlas's unwavering trajectory, as though waiting for the line to tremble to relieve their anxiety. But Atlas remained silent, and that silence grew into the loudest voice of all, a voice science had not yet learned to translate. In this atmosphere, reflections seeped into papers and conferences alike. Some researchers began to write essays tinged with philosophy, suggesting Atlas was a reminder that science always has limits, and that those very limits fuel the drive to seek further. They did not declare Atlas artificial, nor did they deny the possibility. Instead, they emphasized that what mattered was not the answer itself, but the willingness to face the paradox head-on. And within those reflections, scientific bewilderment reached its climax. Atlas was no longer just an object to measure, it had become a mirror held up to the human mind. Every mismatch of numbers, every failed model, reflected the fragility of our faith in laws once thought unshakable. October 2026. Atlas crept ever closer to perihelion, and every eye remained fixed on the smallest possible change in its orbit. But no change came. Its trajectory stayed as straight as a taut steel thread stretched across space, indifferent to the cosmic winds blasting out of its own body. The signal scientists had long hoped to detect a heartbeat of sorts. The faintest sign of non-gravitational acceleration remained absolutely absent, and that absence, after so many months, had grown into an obsession. Inside the meeting rooms of NASA, ESA, JAXA, and CNSA, the atmosphere felt as suffocating as if the world were facing a global crisis. Screens glowed with overlapping graphs, prediction versus observation. But instead of diverging curves or even the comfort of two lines neatly layered, there was only one, the cold, flawless line of pure gravitational orbit, unyielding and impersonal. A researcher finally blurted out in despair, "We've tried everything to find NGA's shadow, but Atlas casts none." By now, scientific bewilderment had swelled into a collective condition. Academic papers began to carry an uncharacteristic tone. Rather than confident declarations, they were filled with hedging phrases, "may be assumed unclear." Some groups even conceded in print, "the NGA mechanism may not be universal to all bodies." It was an unprecedented admission, an implication that one of astronomy's most fundamental principles might be nothing more than a local rule, not a universal truth. Within the scientific community, tension fractured into deep rifts. One faction urged patience, insisting data must be gathered through perihelion and beyond. They believed Atlas could not escape the law forever. But the other faction pushed back, arguing that silence itself was already an answer. Atlas was exposing a crack in the current model, and science needed the courage to face it. Hours-long debates often ended in heavy silence, as no one dared speak the thought all shared. We don't know. Meanwhile, the public grew increasingly unsettled. They followed each update, only to be met with evasive language instead of clarity. Faith in the omnipotence of science began to waver. On forums, questions multiplied. If Newton can't explain this, what else can we trust? If Atlas truly has no NGA, then what is holding it in balance? What had begun as curiosity had evolved into a hunger for knowledge, but the only answer offered was a wall of silence. In the final commentaries before perihelion, many scientists turned philosophical. They wrote that Atlas was like a book with a vital chapter missing. We could read the opening pages, we knew comets erupted, we knew physics demanded orbital drift, but then the next chapter was torn away, leaving a blank expanse. And in that blankness, scientific bewilderment became more than a failure of calculation. It was a confrontation with the limits of understanding itself. One young researcher published in Nature, "Atlas is a mirror. It reflects us to ourselves, a civilization that thought it had mastered the rules, yet is still fumbling in the dark." Perhaps the absence of NGA is the message that the universe always keeps a secret, to remind us of humility. As October drew to a close, Atlas's silence endured, as unwavering as its immutable orbit. And within that silence, scientific bewilderment reached its breaking point. No one could say with certainty what was true, what was false. Atlas had become a living paradox, forcing humanity into a state of tension, doubt, and reflection, a paradox destined to haunt us long after it has vanished from the reach of our telescopes. October 2026. As Atlas drew near perihelion, the focus of observation shifted. Tracking its orbit was no longer enough. The central question had become, what lies inside it? If Atlas's trajectory had already broken every prediction of celestial dynamics, then perhaps its chemistry held the key. To find answers, astronomers turned to their sharpest weapon, spectroscopy. Spectroscopy is the art of splitting light into its component lines, like breaking a symphony down into single notes. Each element, when energized, glows at distinct wavelengths, leaving behind its unique light signature. By studying those lines, scientists can identify the fingerprints of hydrogen, oxygen, carbon, silicon, and even heavier metals like nickel or iron. It is how humanity reads the periodic table written in starlight. For Atlas, this reading became urgent. Infrared telescopes like James Webb were reoriented toward the faint halo surrounding it. Radio observatories such as ALMA in Chile swept across frequencies where gas molecules are known to emit. Meanwhile, ground-based telescopes in Arizona, Hawaii, and Spain, armed with high-resolution spectrographs, collected every photon reflected from Atlas. The torrents of data streamed back to research centers, where supercomputers labored for hours just to process fragments of it. At first, everything unfolded as expected. The familiar spectral lines of water, H2O, appeared clearly. Carbon dioxide, CO2, was present too, though at unusually high levels, echoing earlier anomalies. Methane, CH4, and ammonia, NH3, surfaced faintly in the mix. Scientists breathed easier. At least Atlas still shared some traits with ordinary comets. But that comfort evaporated when another result emerged on their screens. In James Webb's spectra, a series of powerful emission lines flared precisely where nickel reveals itself. Somewhere in the ghostly halo around Atlas, nickel atoms were floating, glowing under the sun's radiation. The discovery drew immediate attention. Nickel is not a typical cometary element. Comet nuclei usually contain iron alongside nickel, since the two metals are bound together in most meteorite structures, but when researchers cross-checked, they uncovered a chilling gap. Iron was absent. The initial shock was like thunder cracking through a laboratory. Researchers stared at one another, unwilling to believe their own instruments. An internal report captured the moment. We expected a cacophony, but Atlas played only a single note, nickel, resonant, and alone. Normally, nickel appears only in trace amounts within comets and is always paired with iron. But in Atlas, nickel stood out in undeniable strength, while iron had vanished, erased as though by an unseen hand. Once this information surfaced, the reaction went beyond surprise. It became a shiver of suspense, the sense of opening a door to a room no one had known existed. If Atlas truly contained abundant nickel but no iron, it pointed to an origin utterly unlike any comet observed before. Could this be the product of some unique astrophysical process, forged in an environment alien to our solar system? Or was it the outcome of something artificial, an intentional act of selection, matter chosen with purpose? The truth remained unproven, but in that moment, Atlas forced the scientific world into collective silence. In the sharp, cold glow of its spectrum, it seemed to be delivering a message, strange, unsettling, written in a language humanity had only begun to decipher. And from that moment onward, Atlas's chemical story began to unfold, one that promised to be even more haunting than the paradox of its orbit. In astronomy, every anomaly must endure the harshest trial of all, repetition. After the shock of nickel without iron, research teams worldwide rushed to verify. Spectrographs in Arizona and Spain carried out independent observations. ALMA focused on an entirely different frequency band, searching for confirmation. Data from James Webb was reprocessed using a completely new algorithm, eliminating any chance of software error. Yet all results, without exception, returned the same verdict. Nickel was undeniably present, iron still absent. Surprise quickly shifted into tense suspense. The entire community seemed to be waiting for a technical glitch to surface, a simple mistake that would dissolve the paradox. But no glitch appeared. Every instrument performed flawlessly. Spectra from different facilities, produced by different methods, lined up like mirror shards reflecting the same image. Atlas was not playing tricks. It truly contained nickel in abundance and iron in silence. The first scientific papers on the anomaly soon appeared. A European team published in Astronomy and Astrophysics, reporting nickel lines with 99.9% confidence. An American group in the Astrophysical Journal emphasized, in every comet ever observed, iron is always present. Atlas is the only exception. A Japanese researcher even reached for a metaphor. If comets are an orchestra, iron is the bass instrument, always playing alongside nickel. But in Atlas, the bass is muted, leaving only nickel's violin playing a lonely solo. From there, suspicion began to stir. Geochemists wondered, could Atlas have formed in a nursery rich in nickel but poor in iron, an environment almost unheard of beyond the solar system? Some astrophysicists proposed nickel might emerge from nuclear decay of heavier elements, though such a process had never been documented in comets. Hypotheses spread like waves, but each opened a wider gap than it closed. In laboratories, tension and doubt colored every discussion. Scientists debated with guarded eyes, wary that any word might be twisted into alien technology. No one dared publicly suggest an artificial origin, yet everyone silently recognized that the data hinted at the possibility. An anonymous researcher wrote in an internal report, "Pure nickel is often found in advanced alloys, such as those used in jet engine chambers. Atlas could be a coincidence, but this coincidence feels too much like design." The public, as always, moved faster than science. On social media, the phrase nickel anomaly became a global trend. Speculative theories exploded. Atlas was a resource mining machine, the relic of an ancient civilization, or a cargo chamber of alloy launched from some distant world. The more wild the theories, the more curiosity burned, and the heavier the pressure grew on the scientific community. Meanwhile, astonishment showed no signs of fading. Instead, it sharpened. Nickel wasn't merely present in the spectra, it blazed at abnormal levels. Some measurements indicated nickel concentrations in Atlas's outgassing were dozens of times higher than in any comet previously recorded. It was like finding a bright red inscription scrawled across the cosmic map, an inscription no one could read. Suspense, suspicion, curiosity, all fused into those weeks. Atlas was no longer only an orbital enigma. It had become a direct challenge to humanity's grasp of cosmic chemistry itself. And with each new step, instead of dissolving uncertainty, it deepened the labyrinth of mystery. November 2026. As Atlas entered its brightest phase before perihelion, New spectral data kept pouring in, and each line of data cut deeper into humanity's collective astonishment. Nickel shone ever more clearly, while iron remained absent. The impossible truth echoed through dozens of conferences, tightening the atmosphere like a stretched wire. At one international online meeting, hundreds of scientists from across the globe attended. The first slide appeared, displaying the emission lines, nickel glowing bright, iron utterly blank. The conference hall fell into silence for several seconds before a European expert finally spoke. If this were a single measurement, I would doubt the instrument. But when 3 telescopes on 3 continents all show the same result, we are facing a real mystery. The words lingered, chilling the room, for they admitted there was no longer any room for familiar excuses. Still, not everyone accepted so easily. One faction clung to possible errors. They argued iron might exist as solid grains too large to radiate within the spectral bands we observed, or perhaps iron's signature was hidden by optical effects caused by dense dust. An American scientist insisted, "There is no reason for nickel to appear without iron in nature. If we don't see iron, it simply means we haven't looked in the right place." The opposing camp pushed back forcefully. They pointed to ALMA's data, which had captured radio signals from metallic molecules. Nickel stood clear there, too, yet iron was silent. A young Japanese researcher declared, "We have scanned every wavelength possible. There is nowhere left for iron to hide. This is not an error, it is truth." Her voice was so firm that the room froze, as if everyone recognized the thin line between skepticism and reluctant admission was vanishing. Suspense deepened when an independent Swiss group released a detailed analysis. The nickel-to-hydrogen ratio in Atlas's outgassing was 20 times higher than in any comet within the solar system. The number was described as a massive exclamation mark scrawled across the equation of cosmic chemistry. One journalist wrote, "Atlas is not whispering a secret, it is screaming at us in the language of nickel." Doubt began to creep toward daring speculation. Some experts asked, could this be the result of a fantastically rare natural process of elemental selection? Or worse, might it be evidence of some kind of technology, a vast-scale manipulation of material? No one dared use the word artificial in official papers, yet the term began appearing in corridor conversations and private messages. Curiosity drove the work forward, but also weighed heavily. Laboratories on Earth ran constant simulations, trying to recreate conditions that could form a comet rich in nickel but poor in iron. Every model failed. Some even explored the nuclear decay hypothesis, that Atlas once contained heavy radioactive elements that decayed into nickel, but the timescales clashed with its orbital data. The more they simulated, the deeper they sank into dead ends. Meanwhile, the public imagination exploded. Popular newspapers compared Atlas to a metal foundry drifting in space. A televised documentary called it the metal paradox. Social media spread images of Atlas reimagined as a massive nickel mining machine, sparking heated debates over where science ended and science fiction began. The line between them blurred, as real data already stretched far beyond the comfort of the familiar. In this atmosphere, astonishment was no longer a momentary shock, but a sustained state, tense, suspicious, endlessly curious. Through the silence of iron and the solitary voice of nickel, Atlas had transformed the entire scientific community into readers of an ancient manuscript, struggling to interpret strange characters while knowing an entire chapter was missing. And it was that void, that paradox, that kept humanity's eyes fixed on the heavens. December 2026. Atlas reached perihelion, blazing so brightly it could be seen with the naked eye from many places on Earth. Yet in that dazzling moment, instead of offering answers, it unveiled a deeper layer of mystery. The latest spectra, gathered from James Webb, ALMA, and ground-based observatories, delivered a final confirmation. Nickel shone strongly, and iron remained completely absent. There was no late arrival of iron to rescue the old hypotheses. Atlas had passed through its most data-rich phase, leaving behind an undeniable imprint, a celestial body glowing in a chemical language never seen before. In an atmosphere taut as a violin string, curiosity had mutated into obsession. Every research group scrambled to propose a definitive explanation. Some argued that nickel might be venting from a core rich in alloys, while iron remained trapped in solid structures. Others speculated that Atlas might have formed in an extraordinarily rare environment, where nickel accumulated more readily than iron. But all such explanations were swiftly dismantled. No model could reproduce such an extreme imbalance. Doubt soon gave way to audacious speculation. At a closed-door conference, a young scientist whispered, "What if this isn't natural? What if the nickel is the residue of some colossal metallurgical process?" The room fell silent before erupting in protest. No one wanted to publicly step into extraterrestrial territory, but the silence that followed left an echo. The idea of technology unwritten, unacknowledged, spread like fire through hallways, private emails, and hushed conversations behind closed doors. The public, of course, felt no need for restraint. They bluntly dubbed Atlas the nickel machine, the flying furnace, or a signal from a lost civilization. Millions of posts on social media revolved around the same haunting question: who left Atlas drifting in the cosmos? Documentaries, podcasts, and even novels rushed to capitalize on the fascination. Atlas, once a scientific enigma, had become a cultural phenomenon where the boundary between research and speculation blurred to a dangerously thin line. Meanwhile, many scientists quietly wrote reflections tinged with philosophy. One compared Atlas's nickel spectrum to a signature, though no one yet knew whose signature it was. "It may be the hand of nature," they mused, "or the hand of intelligence." Another warned, more soberly, "The danger is not that Atlas challenges our knowledge. The danger is how desperate we are to force a quick answer upon it." Such cautions resonated briefly, but were soon drowned out by the tidal wave of curiosity and suspense. As Atlas drifted away from the sun, its brilliance dimmed, but the nickel without iron paradox remained, etched like a scar in humanity's collective memory. The initial shock had hardened into an open-ended question, suspended over the skies of science. Had we just witnessed an extraordinarily rare quirk of nature, or glimpsed the legacy of a technology not born on Earth? No one could answer, and perhaps there would never be a definitive answer. December closed, and Atlas continued its journey, leaving behind an Earth ablaze with debate. In laboratories, in scientific journals, and in the imagination of billions, the name Atlas had become synonymous with endless wonder. It forced us to feel both suspense and doubt, both fascination and unease, not only about one celestial object, but about humanity's very ability to read the hidden language of the universe. Late December 2026. Once the last photon of spectral data had been analyzed, the scientific community returned to a fundamental question: how much does Atlas weigh? The question sounded simple, but inside it lay a chain of paradoxes never seen before. Because if Atlas was truly erupting violently and still showing no trace of non-gravitational acceleration, NGA, then only one reasonable explanation remained. Its mass had to be so enormous that every outgassing thrust became insignificant, like a gust of wind against a mountain wall. To estimate its mass, research teams began with orbital data. Atlas was traveling around the Sun with an astonishingly stable trajectory, not deviating even a millisecond from gravitational models. That stability became a proxy. If an object was small in mass, it would be far more vulnerable to tiny pushes from escaping gas. Yet Atlas held firm against every thrust, like a colossal boulder that would not budge. Based on the intensity of its outburst recorded by telescopes, combined with the absolute absence of NGA, dynamicists calculated that the minimum mass of Atlas had to equal that of a massive mountain on Earth. A European team's report produced a staggering estimate: tens of billions of tons. To help the public imagine it, they compared Atlas's mass to more than the total amount of steel humanity has extracted since the dawn of the Industrial Age. An American team offered another metaphor. Atlas weighed as much as thousands of container superships, all fused into one single body hurtling through space at tens of kilometers per second. A wave of astonishment swept through the scientific world. People were accustomed to thinking of comets as dirty snowballs, fragile, brittle, prone to shattering into fragments when approaching the Sunday. But Atlas now appeared like a fortress of iron, so sturdy and massive that not even the most violent eruptions could nudge it off course. The feeling was like standing before an elephant. After spending your life only watching house cats, you suddenly realized how small your prior knowledge had been. Science journalists quickly seized on vivid analogies. One major paper wrote, "If a leaking pipe can push a skateboard across the floor, then Atlas is a cargo ship, and its outgassing is just a few droplets falling on the deck." A television network described it as a skyscraper racing through space, unmoved by cosmic winds. These images left the public awestruck, because mass was no longer a dry number on a chart, but a symbol of overwhelming weight, far beyond everyday imagination. Inside research centers, astonishment mingled with unease. That colossal mass not only made Atlas unique, it raised a frightening question. If it was too large, had we misjudged its very nature? Comets were supposed to be fragile, but Atlas behaved more like an ice-sheathed asteroid. And if it was in fact an asteroid, then its interstellar origin grew even more bewildering. How could an object so heavy have traveled across the gulfs of interstellar space to arrive here? No immediate answers came. But in the suffocating atmosphere of that year's end, the sense of Atlas's sheer mass gripped everyone's imagination. It was no longer a distant pinpoint of light, but a flying mountain, a colossal stone gliding through the solar system, forcing humanity to look up with wonder, laced by a quiet, lingering suspicion. And this was only the beginning of the mass argument, an argument that would soon lead to even more suspense. The first days of 2027 brought with them the official release of Atlas's mass estimates. And almost immediately, a storm of comparisons erupted not only within the scientific community, but across newspapers, television, and the imagination of the public. For people to truly grasp the staggering scale, they needed metaphors, familiar landmarks to place on the balance beside Atlas. And from those comparisons, astonishment swelled into a global wave of awe. A research group in Germany offered the first striking example. If you set Atlas next to Mount Everest, Everest would be nothing more than a pebble at the foot of a vast cliff. The image flashed across television screens, searing itself into the minds of millions. Atlas was no longer just a distant dot in the sky. It became a super mountain crossing the cosmos, dwarfing every scale humanity knew on Earth. Other analogies soon followed. An American scientist likened Atlas to a colossal interstellar cargo ship. If a leaking pipe can push a skateboard across the floor, then Atlas is like a mega container ship stretching tens of kilometers. You could vent millions of tons of gas, and the ship still wouldn't move an inch. The phrase, cosmic container ship, spread rapidly across social media, turning into memes and a cultural shorthand for Atlas's immovable stability. In Japan, researchers took a more tangible approach. They modeled Atlas's mass against the entire volume of water in Lake Biwa, the country's largest lake. The result? Atlas outweighed it by thousands of times. One Japanese journalist wrote, "If Atlas were to fall into Lake Biwa, it wouldn't just fill the basin, it would force the waters to flood the entire Kansai region." The article horrified readers, grounding the incomprehensible enormity of Atlas in an everyday image familiar to Japanese life. Across Europe, a popular science program staged a 3D animation, a single elephant towering above a swarm of ants. "Atlas is the elephant," the host explained, "and the jets of gas are the ants trying to push it. The elephant doesn't budge. And stranger still, this elephant comes from a forest we have never known." The studio audience sat silent for a moment before erupting into applause, as though grasping both the wonder and the unease in a single breath. The more comparisons piled up, the stronger the sense of awe grew. People began to imagine Atlas not just as a mass of rock and ice, but as a symbol of absolute weight, a flying mountain beyond imagination. Headlines screamed, "The mountain that walks through space, the cargo ship of the cosmos, the object that makes Earth look fragile." Awe was magnified into a global fever, as if the sheer enormity of Atlas had become humanity's newest obsession. Inside research labs, however, awe was laced with tension. For if the colossal mass estimates were accurate, then Atlas was unlike any comet ever recorded. Too heavy, too steady, too unyielding. Scientists began whispering, could we be mistaken? Was Atlas not a fragile, icy comet at all, but a massive asteroid shrouded in dust and gas? Or worse, was something hidden within that immense weight? A hollow structure? A mechanism of artificial design? These doubts were never voiced openly, but they hovered over the scientific community like storm clouds. They knew that with each awe-inspiring comparison, the public's fascination only grew. Yet alongside that fascination came a gnawing suspense. If Atlas truly was a flying mountain, then who or what had sent it into the solar system? January 2027. The colossal mass figures for Atlas had flooded newspapers and ignited public debate, but within the scientific community, the feeling was no longer simple awe. It had shifted into something else, suspense and suspicion. The more calculations that were made, the more unsettling the question became. Were the measurements even correct? Or was science itself walking into a data trap of its own making? At a closed workshop in Paris, a team of dynamicists presented a dissenting report. If Atlas truly weighed as much as current estimates suggested, then its density would far exceed that of any comet ever recorded. That would make it behave less like an icy comet and more like a metallic asteroid. Yet the spectral data clearly revealed vast amounts of water and carbon dioxide. The contradiction hung heavy in the room. One expert finally muttered, "Atlas is like a massive elephant wearing a mask of snowflakes." The real question is, what hides beneath the mask? Doubt spread quickly. One camp argued that the NGA-based mass estimates might have been misinterpreted. Perhaps Atlas had a hollow structure, a wide but thin shell that allowed it to mimic the behavior of a heavy object while being less dense inside. A young scientist offered an analogy. Imagine a giant hollow steel ball. It is still heavy, but not so heavy as to turn every calculation into a paradox. The question is whether Atlas is solid or hollow. Today, the opposing camp countered immediately. If Atlas were hollow, the jets of gas would have sent it spinning chaotically. Yet its trajectory and rotation remain coldly stable. That only proves it is solid, extremely solid. The words echoed, sending a shiver through the room. For a dense, massive, unyielding Atlas pointed to a deeper riddle. Not only was it immense, but it possessed a structure that seemed almost impregnable. Suspense mounted daily as research teams ran simulations on supercomputers. They tweaked densities, adjusted diameters, and even hypothesized that Atlas might contain exotic alloys never before seen. Yet every model converged on the same conclusion. Atlas was too heavy to be a conventional comet. A Swiss group's report summed it up bluntly. Each time we adjust parameters to make Atlas behave like a reasonable comet, the observational data immediately contradicts us. Inside control rooms, the atmosphere grew suffocating. Each new update no longer brought excitement but felt like a hammer striking the foundation of trust. Scientists had to admit, at least privately, they might be confronting an entirely new class of object, and the question pulsed through every conversation. If Atlas is not a comet, then what is it? That doubt began to feed more daring speculations. Some whispered that perhaps Atlas was an artificial structure, a massive body deliberately manufactured or assembled from special materials. None dared write such words in official reports, but private emails and discreet messages betrayed the same quiet fear. Atlas might not be a simple product of nature. Ironically, the silence only heightened the unease. The public, unbound by scientific caution, leapt far ahead. They called Atlas the mothership, the artificial flying mountain, even the mysterious cargo hold drifting through space. And as those theories gained traction, scientists felt cornered, pressed to deliver some definitive explanation. But Atlas offered none. It continued its journey massive, unmoved, immune to every force, leaving suspense, doubt, and a gnawing sense of helplessness as constant companions for the global research community. February 2027. Atlas had passed perihelion and was beginning to drift away, yet instead of leaving answers behind, it carved a heavier void. The final mass figures drawn from an array of models based on orbital data, luminosity, and material density all converged on a single verdict. Atlas was heavier than any comet ever known, far beyond every standard science had grown accustomed to. When the scientific reports were published, they used words rarely found in academic writing: overwhelming, inexplicable, outside the model. These phrases reflected the researchers' true emotions. They were not simply facing an object, but the very limits of their own thinking. At a conference in Geneva, a veteran scientist took the stage, his voice noticeably heavy. The mass of Atlas is enough to drown out every error margin. The jets of gas erupting from it are like dust motes brushing against a wall of steel. It does not waver. It does not sway. It moves as if shaped by an invisible hand. The hall fell silent. The awe in his words was unmistakable, for Atlas was no longer just a subject of observation. It was a mass crushing every prediction beneath its weight. Suspense reached its peak as final hypotheses were laid out. Some teams insisted Atlas must be a disguised metallic asteroid, harboring a special core. Others suspected an unknown physical mechanism, one that distorted mass calculations. But behind every debate, one unspoken question lingered. Could Atlas be an artificial structure? No one dared say it outright, yet the glances, the tones, the hesitations in every presentation betrayed how familiar that thought had become. The suspicion deepened when one group simulated a hollow scenario. If Atlas were hollow, supported by some internal framework, the mass estimates could be lower. But when compared with rotational data, the hollow model collapsed immediately. A hollow body could never maintain such absolute stability. By contrast, when treated as a solid block, every dataset aligned with frightening precision. And it was precisely that perfect alignment that sparked greater doubt. Why would a natural object be so perfect? Among the public, awe evolved into legend. Newspapers christened Atlas the flying mountain of the cosmos, the lost wandering planet, even the giant vault of the stars. People wrote songs, made films, and built theories all orbiting that mysterious heaviness. The sense of astonishment no longer lived only in laboratories. It had become a global experience. In the closing lines of one summary report, a scientist wrote, "The mass of Atlas is not just a number. It is a message from the universe that we still know very little about the diversity of matter beyond our world. It reminds us that there will always be colossal weights, both in physics and in knowledge, that humanity is not yet strong enough to bear." And so, as Atlas faded from view, it left behind not just a trajectory, but a fusion of awe, astonishment, suspense, and doubt. The object itself had moved on, but its shadow, the shadow of that immense mass, would press upon humanity's memory for a very long time. March 2027. While Atlas's staggering mass figures were still shaking the scientific community, researchers began to glance back toward the recent past, to a name that once left the world equally bewildered: Oumuamua. In 2017, when the first interstellar object was recorded sweeping through the solar system, it brought with it a chain of unanswered questions. Now, with Atlas, that same sensation had returned, but this time stronger, deeper, and carrying the weight of an awakening. Oumuamua appeared without warning, moving with a speed and trajectory that proved it did not belong to our solar system. From the beginning, its elongated, cigar-like shape ignited fierce debate. Unlike any asteroid or comet ever observed, Oumuamua bore no trailing dust tail, no shimmering halo of gas. It was merely a cold, solitary fragment, rotating slowly and reflecting sunlight in a strangely inconsistent way. Scientists scrambled for explanations. Perhaps it was debris from a distant planet, or the bare nucleus of a comet stripped of its ice. Yet each hypothesis collapsed under scrutiny. What made Oumuamua a true paradox was not just its shape, but its motion. As it receded from the sun, it experienced a gentle, unexplained acceleration, what should have been a non-gravitational force caused by outgassing. But there was no gas, no dust, nothing to account for it. This invisible push broke the mechanical models. Researchers, uncharacteristically cautious, resorted to words rarely used in scientific discourse. We are not certain. An unknown mechanism may exist. Some even dared to suggest that Oumuamua might be a light sail, an artificial structure, thin and delicate, propelled by solar radiation. Yet science, cautious by nature, chose silence in the face of such a bold claim. The search for natural explanations continued, even as every scenario proved riddled with holes. One astronomer confessed, "Oumuamua was like a puzzle piece from a game we've never played. We held one fragment in our hands and tried to guess the entire picture. The difference she'd for the wellent around of their keepless actions, which the Portsons parents." Over time, the event faded from the public's memory. Oumuamua became a familiar name in popular science articles, but it no longer sat at the heart of heated debate. Within the scientific community, however, it lingered as an unresolved echo. Researchers quietly hoped it was merely an exception, a cosmic accident, a one-off anomaly never to repeat. But when Atlas emerged in 2026, that hope disintegrated. The scientific world was stunned to realize Oumuamua could no longer be dismissed as a solitary quirk. With Atlas, the chain of paradoxes not only reappeared but grew more complex, more intense, and more defiant. Oumuamua had cracked the wall of knowledge. Atlas, just a decade later, had widened that crack into a fissure, forcing humanity to peer into the darkness beyond. That is why, in the spring of 2027, at international conferences, the name Oumuamua suddenly resurfaced with striking frequency. It was no longer a distant memory but the beginning of a pattern. And now Atlas had joined it a second piece, compelling everyone to ask, if twice in 10 years we have encountered impossible objects, can this still be a coincidence? Or is the universe deliberately sending us a message? The unease, tension, and curiosity seeped into every discussion. Revisiting Oumuamua was not simply recalling a mystery, it was admitting that humanity had missed an opportunity. We let it slip away, no probe sent to chase it, no detailed data preserved. And now, with Atlas, that omission resounded like a warning. Oumuamua, the object gone forever, had become a ghostly reminder. We cannot allow the universe to keep asking questions while we answer only with silence. At the conferences of early 2027, one phrase echoed again and again. Oumuamua and Atlas, two mirrors reflecting the same paradox. The comparison was more than technical. It carried a profound unease. Humanity was no longer witnessing an exception, but a pattern. The first parallel that stunned the community was non-gravitational acceleration. Oumuamua accelerated as it left the sun, yet no dust or gas explained the phenomenon. Atlas, on the other hand, erupted violently, venting massive streams of dust and gas, yet displayed absolutely no non-gravitational acceleration. One object showed a force without a source, the other showed a source without a force. Two opposing paradoxes, strangely complementary, like two halves of an unfinished equation. The second parallel was the deep sense of not fitting. Oumuamua refused to fit into any known model of asteroid or comet. Atlas, too, defied categories. Its mass, its chemical composition, its unwavering orbital stability, all contradicted the norms. A Cambridge scientist put it poetically. If Oumuamua was a question, then Atlas is the answer, but one that leaves us twice as unsettled. Their differences only further fueled curiosity. Oumuamua was small, faint, and fleeting, visible for only a few short months before it disappeared forever. Atlas was the opposite, brilliant, prolonged, tracked for years with the most powerful instruments humanity possessed. And yet, this contrast only sharpened the tension. If Oumuamua could be dismissed as insufficient data, Atlas destroyed that excuse. We had the data, we had the time, and still, instead of resolving the mystery, the data opened wider gaps. During discussions, comparison charts were projected like cold reminders. On one side, Oumuamua's velocity curve, small but deviating from gravitational models. On the other hand, Atlas's trajectory, straight as a steel wire, is unmoved by violent outgassing storms. The conference halls stared at those two graphs and felt the same dawning realization. An awakening was approaching. The tension was most visible in the questions scientists dared to ask. A young astronomer from Chile spoke plainly. If there had only been Oumuamua, we might call it an exception. If there had only been Atlas, we might call it an anomaly. But when both exist within a single decade, what else can it be, if not a message? The room fell silent. No one wanted to admit it, but all understood. Two consecutive enigmas had carved a hole in our knowledge that could not be patched. In the public sphere, the comparison struck even harder. The media dubbed Oumuamua the opening riddle, and Atlas the second chapter of the interstellar paradox. Articles proclaimed that the universe was no longer whispering but pounding on the door of human perception. Headlines multiplied. From Oumuamua to Atlas, is the universe teaching us humility? Age to speakle, bewilderment, tension, and curiosity swirled together in those days. Placing Oumuamua beside Atlas, the world was no longer just discussing numbers. It was confronting repetition, and repetition was what made humanity shiver. It was like a bell tolling in the dark, signaling that the cosmos still held unwritten rules, still hid chapters of its book that we had yet to read. As the comparison charts of Oumuamua and Atlas were displayed at the conferences of early 2027, the mood within the scientific community began to shift from debate to something else: awakening. No one could deny it any longer. Both interstellar objects had carved a visible breach into the wall of knowledge humanity had confidently built over centuries. It felt like a fog lifting. For years, scientists had labeled whatever they couldn't explain as an exception. Exceptions were a way to preserve the framework, to tape over cracks without tearing down the wall. Oumuamua had been handled this way. Too little data, too strange a shape, so it was filed under anomaly and left behind. But Atlas, with its months-long appearance, its avalanche of data, and its glaring paradoxes, made the exception option impossible. And that impossibility forced the community for the first time to admit, we are staring at a genuine hole in our understanding. Papers began appearing in a different tone. Gone were the confident declarations. In their place were weighty, honest phrases. We do not yet understand, An unknown mechanism may exist. Atlas and Oumuamua compel us to reopen chapters we thought were closed. A senior Harvard astronomer wrote, "Science has grown accustomed to living in the light, but Atlas reminds us that light shines only on a very small corner of the cosmic map. The rest remains in shadow." This awakening did not stop at theory. It spilled into philosophical debate among researchers. Some invoked Richard Feynman's famous line, "It doesn't matter how smart you are. If theory doesn't fit reality, it's wrong." With Oumuamua and Atlas, reality was pounding on the door. The two objects stood like stern teachers, forcing humanity to accept a failing grade and rewrite the test. In public forums, scientists no longer concealed their emotions. One remarked, "Atlas is a wake-up bell. It shows us that paradox doesn't appear once and vanish, it can repeat, and when paradox repeats, the flaw isn't in the universe, but in the way we've chosen to see it." These words were quoted across headlines, spreading like a new declaration. The time had come to acknowledge the whole rather than hide it. Tension, of course, remained. No one wanted to admit that centuries of accumulated knowledge might be gravely incomplete. Yet alongside, the tension burned a fierce curiosity. If there truly were an unwritten chapter in the book of physics, what would it say? A new kind of force? A law never described? Or the possibility that sent chills down spines, a sign of intelligence beyond humanity? The public followed these developments with unprecedented fascination. Articles comparing Oumuamua and Atlas were shared millions of times, accompanied by stunned comments. "We thought we understood the universe, but we've only read the prologue." Many began calling the two objects the twins of awakening. Oumuamua, the first shard thrown at humanity. Atlas, the second, forcing us to finally face what we had turned away from. And in that moment, humanity felt a truth both simple and profound. Knowledge is not a fortress wall, but a fragile bridge stretched across the abyss of ignorance. Oumuamua had shaken that bridge, Atlas had cracked it, and now our task is to rebuild this time with greater humility. As the spring of 2027 unfolded, in the conference halls of scientists and in the public forums broadcast to millions, a phrase echoed with growing insistence: improbable becomes possible. What once seemed unthinkable was now a fixture of scientific life. Oumuamua had been considered an impossible case, a strange interstellar visitor, one of a kind, passing silently and never to return. But 10 years later came Atlas, and its arrival stripped humanity of the right to call it a coincidence. What had been improbable was now something we were forced to face. This realization ignited a wave of deep reflection. Scientists began writing essays no longer confined to technical analysis, but saturated with contemplation. A feature in Nature declared, "Oumuamua gave us the question. Atlas reminded us." Together they form a message. Human knowledge is not a finished map, but a few rough sketches on uncharted land. A philosopher of science noted, when the improbable repeats, it ceases to be improbable. It becomes evidence that something fundamental has been overlooked. Among the public, this sentiment spread like a collective awakening. Science programs began discussing not just orbital paths and spectral lines, but the human meaning behind them. How much do we really know of the universe? If, in just 10 years, two objects have shattered every model, how many more are waiting to be discovered? A journalist wrote, "The universe is not only larger than our imagination, it is stranger than imagination can contain." The tension did not fade, but it transformed into drive. Space agencies began openly debating the need to prepare probes for the next interstellar visitors. No one wanted to repeat the mistake of Oumuamua, letting it slip away in silence, leaving behind only arguments and empty hypotheses. Atlas had taught a hard lesson. More data does not guarantee answers, but at the very least, it forces us to confront the voids in our knowledge. The next lesson must be this: do not wait passively. Seek, prepare, and meet the unknown halfway. In the closing lectures of the conference season, many scientists spoke more candidly than ever before. One declares, "We must learn to live with paradox. The universe is under no obligation to fit our models. Instead of bending it to our frameworks, we should let it lead the way." Another concluded, "Oumuamua and Atlas did not come to answer us, but to awaken us. That is their greatest gift." The public received these words like a breath of fresh air. From classrooms to science forums to casual conversations, people spoke of Oumuamua and Atlas as twin emblems of humility. They reminded us that no matter how far we have traveled in discovery, we remain travelers, still learning to sound out the alphabet of the cosmos. And so, main idea 6 closed on a note both tense and luminous. Awakening was not about finding answers, but about recognizing the questions we had long ignored. Oumuamua and Atlas, two fleeting silhouettes across the sky, had inscribed a new chapter in the history of knowledge, a chapter of humility, of unease, and of the relentless desire to continue seeking once the improbable had become possible. April 2027. After the successive revelations about Atlas, from its unmoving trajectory to its overwhelming mass to its paradoxical chemical makeup, the global atmosphere was stretched tight as a wire. Headlines everywhere carried the phrase, "unexplained object." Television ran daily updates, while social media swarmed with outlandish theories, everything from alien mothership to harbinger of apocalypse. The flood of speculation left the public both curious and anxious, as though humanity stood at a vast crossroads with no clear sense of direction. In moments like this, people instinctively seek an anchor. History had shown that when science was not yet strong enough, humans turned to faith, myth, or supernatural stories for comfort. But this era was different. Amid fake news and swelling fear, the world's space agencies, NASA, ESA, JAXA, CNSA, decided to release a series of comprehensive reports. The goal was not only transparency, but reassurance. Science would remain the anchor in a storm of uncertainty. The reports began with a simple principle. Any phenomenon, no matter how unusual, must be placed in context through comparison. Atlas, in other words, could not be viewed as a solitary enigma, but as one object measured against thousands of comets recorded before it. This message brought a strange calm. No matter how bewildering Atlas seemed, it was still being analyzed with the same tools that had helped humanity understand hundreds of other cosmic mysteries. At press briefings, the tone of scientists shifted. No longer defensive or combative, they spoke with steady, deliberate clarity. A NASA specialist explained, "Atlas is different, yes. But the difference only matters when we have a baseline for comparison. It is this comparison that proves science is not out of control, but on course, using the ordinary to illuminate the extraordinary." Broadcast live, words like these provided comfort to millions watching from their living rooms. Across society, reactions began to evolve. Where forums had once overflowed with doomsday prophecies, a new thread of discussion emerged. How will science explain this? People cared less about whether Atlas was a spaceship and more about how scientists measured, verified, and cross-checked their data. Documentaries explaining how the James Webb Telescope works, or the principles of spectroscopy, unexpectedly hit record viewership. Curiosity began to replace fear, and in that shift sprouted the first seeds of hope. Yet reassurance required more than words, it demanded proof of method. That was when the concept of the control experiment became a kind of cultural medicine. Experts stressed, "We are not only looking at Atlas, we are comparing Atlas to Comet 67P, to Hale-Bopp, to hundreds of other objects. We are repeating the method, and it is the consistency itself that anchors us." For the public, this was soothing. Atlas no longer seemed like a random monster crashing into the solar system, but a rare case being tested within the same framework that had already succeeded countless times before. Put another way, humanity was not free-falling into the dark, we still held the flashlight of data. And so, from the chaos, a quiet sense of scientific reassurance began to spread. Atlas remained a mystery, but at least humanity knew it had not lost its method. And as long as the method endured, even if the answers were slow in coming, hope remained intact. To calm public unease, international scientific agencies did more than offer vague reassurances. They openly shared the full framework of their control experiments. The principle was clear. To know how Atlas differed, one first had to place it side by side with familiar objects. Only then could science demonstrate that, even when paradoxes arise, they are still illuminated under the same light of reason. The first example presented was 67P, divided by Churyumov-Gerasimenko, the comet visited by the Rosetta spacecraft in 2014. 67P vented CO2H2O and displayed unmistakable non-gravitational accelerations in its orbit, exactly as textbooks predicted. Its data became the measuring stick against which Atlas was compared. When the public was shown the side-by-side graphs, they saw two curves. 67P's orbit bending slightly with each outburst, while Atlas remained as straight and rigid as steel. The visual comparison made Atlas's strangeness tangible, yet it also confirmed that the measuring system was valid after all. It had already succeeded with 67P. Next, scientists used Hale-Bopp, one of the brightest comets of the 20th century, as another control. Hale-Bopp's eruptions were so violent that they shifted its orbit by hundreds of kilometers. Scientific reports from the 1990 seconds unanimously documented this. Placed alongside Atlas, the contrast was stark, almost black and white. One object blown off course by cosmic winds, the other unmoved, despite equally fierce outgassing. The message was clear. Atlas was different, but its data were no illusion. Decades earlier, science had already measured the very effect that Atlas now seemed to defy. Experts also presented comparisons with smaller, less famous comets from Encke to Tempel 1. Every one of them followed the same law. The stronger the eruption, the greater the non-gravitational acceleration. Atlas alone broke this trend, and by showing that all other comets behaved by the book, the scientific community reassured itself and the public alike. Science was not adrift, only Atlas had stepped out of line. At press conferences, specialists called this process a global control test. An ESA scientist explained, "We've done what any chemist or biologist would do, use a control sample to validate the result. Atlas may be unruly, but every other comet is not. That means the instruments and the methodology remain sound. It is only Atlas that challenges us." Broadcast live, statements like these served as potent reassurance. The public embraced these examples with surprising enthusiasm. Where once terms like non-gravitational acceleration or spectroscopy had felt intimidating, the concrete comparisons, 67P shifting, Hale-Bopp shifting dramatically, Atlas not shifting at all, made the paradox easy to picture. Instead of sinking into vague fear, people began to feel as if they were attending an open classroom, where transparent data and logic still formed the foundation. The result was a spreading sense of scientific reassurance. People came to understand that if Atlas was different, its difference stood out precisely because it was measured against hundreds of well-understood objects. In other words, one exception did not topple the system. It only reminded the system that it might need to expand to include it. And that reassurance opened the door to other feelings. A sharper curiosity about what made Atlas unique, and a cautious hope that its final answer would push science to a higher rung. Once the control experiments had been widely publicized, the next step for the scientific community was to strengthen trust with something even more vital: the consistency and transparency of the data. For while the public had found some reassurance in comparisons with familiar comets, one lingering question still hovered in the air. Could Atlas's data have been distorted, trimmed, or even hidden? To dispel that doubt, space agencies worldwide flung open their digital vaults. For the first time, the public could access terabytes of raw information. Orbital curves tracked by the Rubin Observatory, detailed spectroscopic readings from James Webb and ALMA, all laid bare. Files once reserved for experts were made freely available, accompanied by explanatory guides, so that any student, teacher, or amateur astronomer could study them firsthand. The move had an immediate powerful effect. Amateur astronomy groups across the globe began downloading the datasets and running their own analyses. They rebuilt the graphs, and to their astonishment, every result matched the official reports perfectly. There was no sleight of hand, no doctored numbers. Atlas truly held its trajectory with absolute steadiness, truly vented nickel with no trace of iron, and truly carried a mass as colossal as a flying mountain. That consistency soothed the quiet unease still rippling through society. Instead of feeling like helpless spectators at some opaque scientific drama, the public now became participants in the process of discovery. They could touch the data, see the same curves, the same spectra, the same figures that the professionals were seeing. A high school teacher in Canada wrote online, "For the first time, I can show my students real data, not just illustrations. They're amazed, but more importantly, they feel trust." This transparency also shifted the tone of the media. Where headlines had once leaned on the sensational Atlas, alien mothership, they now began publishing articles that guided readers through the process of verifying data themselves. A popular science magazine even launched a campaign called Atlas for Everyone, urging readers to download the datasets, redraw the graphs, and share their findings. Panic slowly gave way to a new form of collective scientific reassurance. When everyone stared at the same truth, rumor lost its power. At conferences, scientists admitted openly that they, too, found comfort in the fidelity of the numbers. An ESA expert remarked, "We don't need to embellish or conceal. Atlas is unusual, yes, but the measurements remain faithful. That fidelity is our anchor." An American researcher added, "When you see data from 3 continents, using 3 different instruments, all blending into one harmony, you realize science is not a chaotic crowd, it's a grand orchestra playing the same score." For the public, such statements planted a new seed, hope. If the data were consistent, if the methods were transparent, then all that remained was time to decode the mystery. And this hope did not come from blind faith, but from the lived experience of touching the truth themselves. Atlas remained an enigma, but now it was an enigma contained within the frame of a transparent system, and that frame gave people peace of mind. May 2027. As Atlas began to drift away from perihelion, its glow fading from the sky, a very different kind of light flared within society. The fire of curiosity and hope, brighter than ever before. After months of turbulence and confusion, people no longer felt abandoned in uncertainty. They had something to hold on to: the data, the control experiments, the transparency of the scientific community. And from that foundation of reassurance, a new sentiment began to take root. The hope that today's paradox could become tomorrow's knowledge. Across online forums, instead of apocalyptic theories spreading like wildfire, people started asking simple but vital questions. Could Atlas help us uncover a new law of physics? Might this be evidence that matter beyond our solar system forms in ways we've never imagined? Curiosity gradually took on a constructive form. Rather than indulging in baseless speculation, discussion groups began focusing on learning scientific methods themselves. How spectroscopy reveals elements, how non-gravitational acceleration is calculated, how supercomputers model mass. In its own way, society was learning to speak the language of the cosmos again. In classrooms, teachers seized the chance to turn Atlas into a living lesson. Students were asked to sketch orbital graphs, comparing Atlas with Hale-Bopp or 67P. Many children, encountering the concept of control experiment for the first time, exclaimed with delight, "Oh, so science is like testing a recipe. You try it again and again to be sure." That familiarity transformed curiosity from a source of anxiety into a spark for learning. The public, too, began to dream bigger. Civil groups launched campaigns urging the development of rapid response probes, ready to chase the next interstellar visitor. Articles with headlines like, "We must prepare for the third Oumuamua," and "Atlas cannot be another missed opportunity," spread widely. Hope stopped being abstract and started taking shape in tangible proposals, improving ion engines, advancing solar sail technology, and fostering international cooperation to share the cost of launching a pursuit mission. Within the scientific community, this sense of hope resonated clearly in tone and language. At a press briefing, an ESA researcher remarked, "Atlas has given us a colossal question, but what's extraordinary is that the question hasn't paralyzed us, it's pushed us to act. Science has always turned paradoxes into opportunities. Why should this time be any different?" The statement was quoted around the world, becoming a rallying cry for a younger generation stepping into astronomy. As Atlas receded into the distance, leaving behind a sky that seemed once again familiar, something irreversible had shifted within humanity. We had learned that science is not just a vault of formulas and laws, it is a journey of embracing uncertainty, then transforming that uncertainty into a stepping stone. Atlas may not yet be explained, but it planted a greater seed, the hope that the universe still holds countless secrets, and that humanity has the capacity to reach for them. And so, Main Idea 7 closed in a state of balance. Scientific reassurance steadied us against fear, curiosity propelled us toward new questions, and hope opened the horizon toward the future. Atlas remained an enigma, but instead of frightening us, it became an inspiration, a reminder that even without final answers, the quest itself is reason enough to keep moving forward. June 2027. Once the scientific reports had settled and the public had found a measure of reassurance, another wave began to rise, no longer centered on raw data or orbital paths, but probing deeper, the philosophical and ontological foundations of science itself. Atlas did not merely bewilder astronomers, It shook the very framework of what it means to call something a natural object. And from that fault line, the dominant mood shifted toward doubt about the things we had long believed to be certain. In philosophy departments across the world, lecture halls suddenly overflowed. Scholars asked questions that once seemed like word games. What is an object? Previously, such a query sounded abstract, almost playful, but with Atlas, it became an obsession. If a comet could erupt violently without deviating from its orbit, if it could contain nickel but lack iron, if its mass could exceed every established model, then was the definition of comet still valid? Or did Atlas demand an entirely new category of being, one that stretched beyond familiar boundaries? This wave of doubt did not stop in laboratories or classrooms. On online forums, ordinary people began to wonder, if we cannot be sure about the nature of something as simple as a comet, then can we be certain about anything else in the universe? These discussions carried a faint tremor of unease. Humanity was beginning to realize that the bedrock of knowledge, once thought unshakable, could be unsettled by a single wandering speck of light across the night sky. Many philosophers compared Atlas to the moment when Galileo lifted a telescope to the heavens and discovered that the moon had mountains and valleys, not the perfect smoothness people had long imagined. At that time, astonishment rippled across Europe. What the naked eye had trusted was not the whole truth. Now, Atlas recreated that shock at a planetary scale. A single celestial body had thrown doubt on the very laws and categories upon which an entire civilization had built its understanding. Contemporary philosophical essays seized on this new depth. A writer in Paris observed, "Atlas is not merely a scientific paradox, but an ontological one. It forces us to confront the line between the natural and the artificial, between what is knowable and what forever escapes our grasp." In New York, an existentialist philosopher reflected, "We are not bewildered because of missing data. We are bewildered because Atlas exposes the limits of the very language we use to name things." In everyday society, this doubt spilled into endless conversations. People looked up at the night sky with a blend of awe and unease. A high school teacher in Mexico admitted on a radio program, "I used to tell my students that comets were just dirty snowballs. Now, I cannot say that with certainty. I have to be honest. We don't know for sure." And strangely enough, that honesty makes them listen more intently than ever. Such confessions revealed Atlas's real impact, not confined to telescope control rooms, but infiltrating classrooms, coffee shops, and social media feeds. Doubt was no longer the privilege of philosophers or scientists. It had become a shared global experience. And within this collective restlessness, something surprising emerged. A renewed interest in philosophy itself, a discipline often dismissed as detached from reality. Atlas had turned abstract concepts like ontology and epistemology into urgent, everyday concerns. The question, "What can we know?" was no longer confined to academic journals. It was now tethered to a celestial body passing through the solar system, a question that anyone, anywhere, had the right to ask. As philosophical debates about Atlas spread, many scholars began revisiting case studies from the history of science in search of grounding. After all, Atlas was not the first time human knowledge had been shaken to its core. Every era has faced moments when doubt shattered old certainties, only to open the door to an entirely new age. And it was within that historical current that people found themselves both restless and astonished. Perhaps Atlas was not a catastrophe for knowledge, but an opportunity to reflect on the very trajectory of science itself. They recalled Copernicus in the 16th century, the man who dared to question the center of the universe. Before him, the geocentric model was the absolute truth. The sun and planets circled Earth. But when he proposed heliocentrism, doubt exploded. Society trembled. If Earth was not the center, what then was humanity's place in the cosmos? In that moment, the astonishment was no less than today's, for a single celestial body was enough to overturn the entire framework of knowledge. And like Atlas, Copernicus's model was not immediately accepted, yet it sparked a wave of change that could never be reversed. Then came Newton in the 17th century. With his Principia Mathematica, the world was handed a mathematical language that explained both the fall of an apple and the movement of the planets. The old division between heaven and earth collapsed into a single law. But what is striking is that before Newton, no one believed a simple equation could unify the universe. Many thought it impossible. Newton turned the improbable into the possible, and the doubts of his era became the bedrock of modern certainty. By the 20th century, Einstein once again shook the scientific world. Relativity directly challenged millennia of intuition. Time was not absolute, space could bend. In its early years, skepticism was nearly universal. Some dismissed relativity as a mathematical prank, but when the solar eclipse of 1919 proved that light itself could curve, unease gave way to awe. Once more knowledge retreated to make room for a new framework. And as if in a double strike, quantum mechanics emerged. From the double-slit experiment to the collapse of determinism, humanity was forced to face a bizarre reality. Particles could be both waves and matter, and position and velocity could never be known at once. Einstein himself resisted, famously saying, "God does not play dice with the universe." But science had no choice but to embrace uncertainty, for experiment after experiment confirmed it. Again, what once seemed improbable had become possible. Through this lens, Atlas appeared not as an anomaly, but as a continuation. It compelled humanity to doubt not only its equations or models, but the very concept of what a natural object might be. If Copernicus took away the center, if Newton united heaven and earth, if Einstein bent space and time, then Atlas was now shaking the conviction that we understand how matter behaves at all. Scholars emphasized that in every age, the first emotions were always doubt and unease. People feared knowledge itself might collapse, yet it was precisely that astonishment which opened the gate to new theories. Atlas, in this way, may be playing the role of a living case study, reminding us that knowledge is never complete. At philosophy conferences, a phrase began to echo: Atlas is the Galileo of the 21st century. Just as Galileo once lifted a telescope and discovered the moon was imperfect, Atlas was now showing us that the most seemingly secure definitions, what a comet is, what an object is, may all be wrong. And it is that doubt, rather than paralyzing us, that signals the beginning of a new journey. The debates gradually moved beyond the boundaries of empirical science and touched the very core of philosophy. Ontology, the study of existence, of what is real. Atlas, through its defiance of every expectation, opened a zone of unease unlike anything before. The question was no longer simply, what is a comet, but something far broader. Do we still even understand what an object truly is? In the Fries null resluching, in philosophy departments, the old frameworks were brought back into play. Plato once said that things are only shadows of their ideal forms. But if Atlas is a shadow, then where is its ideal form? No model fits. Aristotle defined objects by 4 causes: material, form, purpose, and motion. Yet Atlas resists all 4. Its material is irregular, its form unstable, its purpose unknowable, and its motion defies every familiar law. The unease was captured by a philosopher at Oxford. If we cannot classify Atlas comet, asteroid, or anything else, doesn't that mean our system of classification has collapsed? Questions like this force society to confront an unsettling truth. Even the most fundamental concepts we use to define reality may no longer hold. What was astonishing was how Atlas dismantled knowledge not with violence, but with cold silence. It did not explode, did not collide, did not send artificial signals. It simply drifted onward, yet every observation stripped away a familiar assumption. One commentator called Atlas the silent teacher. It said nothing, but compelled us to question everything. Existential philosophers saw in Atlas a massive metaphor. If reality itself is no longer secure, then humanity must learn to live in the in-between, a place where knowledge can collapse at any moment, where doubt is the default condition. Some quoted Kierkegaard, "Anxiety is the dizziness of freedom." Atlas, they argued, is humanity's collective dizziness, forcing us to confront the terrifying freedom of a universe unbound by our definitions. This created a double-edged feeling across society. On one hand, people felt deeply unsettled as their trusted categories suddenly grew fragile. On the other hand, that very fragility became strangely alluring. Philosophical curiosity, once considered remote from daily life, now entered ordinary conversations. If Atlas doesn't fit our definitions, what else out there might not fit? Such questions no longer stayed within lecture halls. They echoed in cafes, on podcasts, and in social media posts. Analogies poured forth. A philosopher compared Atlas to Schrödinger's cat, existing in a state both fitting and not fitting our categories. A physicist called it a translation error in the language of the universe. When we try to read it with our old dictionary, every sentence comes out meaningless. These comparisons, blending science and philosophy, brought a surprising intimacy, making the public feel that ontology was no longer abstract but a necessary lens to grasp Atlas's paradox. But the most important shift was this. Doubt itself became a collective experience. No one dared to proclaim their knowledge to be absolute anymore. Atlas, through its silent presence, had sown a deep caution that whatever we believe certain today may, by tomorrow, prove nothing more than an outdated definition. And in that space of uncertainty, unease and wonder intertwined, leaving humanity suspended, half fearful, half entranced. June closed with a peculiar atmosphere. No longer fear, not merely curiosity. It was a state of collective doubt, stretched wide and humming through society like an underground current. Atlas was no longer just an object drifting through the solar system. It had become an ontological mirror, reflecting the limits of how humanity perceives reality. At a philosophy conference in Berlin, a scholar opened with a question. Are we sure that what we call reality actually exists the way we think it does? The room fell silent. Atlas had already shown that definitions once treated as bedrock comet, acceleration, mass, chemical composition, could all be shaken by a single phenomenon. If that was true, perhaps the entire system of cosmic classification humanity had built was nothing more than temporary walls, waiting to collapse the moment new data appeared. A sense of unease seeped even into the scientific community. An astronomer from Japan wrote, "We don't know what Atlas is, but Atlas knows how to show us that we don't know." The truth was as cold as it was undeniable. It reminded many of the birth of quantum mechanics, when scientists had to admit that the microscopic world did not behave like the macroscopic one. Now, Atlas forced a similar concession on a cosmic scale. Interstellar objects may not obey the script we assumed was universal. The wonder lay in how Atlas shocked without spectacle. It sent no signals, caused no collisions, produced no explosions. It simply drifted straight, heavy, silent, and that very excess of normalcy became its abnormality. One philosopher called it a static paradox, not because it did too much, but because it did too little. And in that little, it unsettled every theory. Some ontologists began proposing a new framework, layered reality. In their view, Atlas suggested we might be applying the definitions of one layer of knowledge to an entirely different layer of existence. Just as Newton's laws fail at the quantum scale, perhaps using the word comet for Atlas was itself an ontological error. The thought left many shivering, for it implied the existence of countless overlapping layers of reality, of which we have barely touched the thin surface above. Among the public, debates grew fierce. Some argued that Atlas was merely an outlier, destined to be forgotten once more data arrived. But a growing number felt otherwise. If within 10 years we had already encountered two impossible objects, Oumuamua and Atlas, then coincidence was no longer a plausible excuse. Doubt, instead of being dismissed as weakness, began to be accepted as part of intellectual maturity. As June came to a close, a German philosopher wrote, "Atlas does not only make us doubt it makes us doubt ourselves, doubt that we were too quick to believe the universe had been neatly ordered. But from this doubt, a door opens the door to a new ontology, where reality is not a fortress of permanence, but a river in constant change." And so, main idea 8 ended in the climax of doubt. Unease and wonder still lingered, but they were no longer feelings of helplessness. They had become fuel, pushing humanity to admit its limits, to reopen its questions, and to prepare for the next journey of knowledge. Atlas, in silence, had turned itself into a mirror, not only reflecting the cosmos, but reflecting us. July 2027. The atmosphere of the world had shifted once again, no longer merely philosophical wonder or ontological unease. It had entered a new state, a suspense so sharp it made people shiver. From the earliest reports, one phrase began appearing with increasing frequency in classified documents: not entirely natural. Even the most cautious scientists were now forced to admit that Atlas's behavior fit no known physical model. Nickel eruptions devoid of iron, a trajectory unmoved by non-gravitational forces, a mass that surpassed all projections. Each detail pointed toward a structure too precise, too deliberate, to be dismissed as coincidence. And at that moment, suspicion escaped the confines of the laboratory. It began to seep into the halls of power, A leaked report from the United Nations Committee on Science and International Security contained one red underlined passage that stunned the world. If Atlas exhibits artificial characteristics, it may be classified as a probe with the potential to observe Earth from interstellar distance. Though presented only as a hypothesis, the words were enough to turn national briefings into rooms taut as bowstrings. Presidents, prime ministers, and defense ministers found themselves confronting a possibility absent from every security doctrine: technology, not of human origin. The public never heard the word probe directly, but enough leaks and half-statements flickered into view to trigger an atmosphere of dread and obsession. Major news outlets reported cautiously, repeating the mantra, "Extraordinary claims require extraordinary evidence." Yet the more the word extraordinary was emphasized, the more chills spread. Never before had an object in the sky silenced the superpowers so completely. In Washington, the Pentagon convened emergency sessions with NASA and DARPA. The questions had evolved. No longer, what is Atlas? But what can Atlas do? If it were artificial, could it conduct military surveillance? Could it contain communication technology or worse, defensive systems beyond human imagination? These questions echoed down the corridors of Congress. In Beijing, the mood was equally fraught. Chinese intelligence agencies monitored every move by the U.S. and Europe, fearing that any proof of artificiality might be withheld for technological advantage. Secret meetings were convened in Shanghai and Beijing, with scientists and military officers sitting side by side. If Atlas was a cosmic Trojan horse, could it be exploited or weaponized in an unprecedented technological war? Moscow, meanwhile, played its familiar card, sowing ambiguity. State television stressed a wild hypothesis that perhaps the West itself had created or launched Atlas decades ago. Implausible though it sounded, the accusation planted seeds of doubt among the public. Whether intentional or not, this fog of uncertainty only deepened global unease. And still, the phrase, "not entirely natural," hung like a blade in the air. It did not declare Atlas artificial, but neither did it deny the possibility. It left a shadowed space open, and inside that space, political imagination ran wild. Security analysts began calling it the dangerous gap, a vacuum where no one had solid information, but everyone acted as though the worst-case scenario might be true. For the public, the most chilling aspect was not the possibility of artificial origin, but the silence. Governments no longer issue frequent statements. Scientific press conferences dwindled, replaced by long, closed-door meetings. As official words grew scarce, rumors multiplied. Some whispered that Atlas might be ancient technology, launched millions of years ago by a distant civilization. Others obsessed over the idea that Atlas was not merely passing by but watching, an unblinking eye fixed on Earth. And so, as the world crossed into the second half of 2027, it did so under suffocating tension, suspense, anxiety, and doubt interwoven. Atlas was no longer just a scientific enigma, it had become a geopolitical variable, a silent threat shaping the fears behind every decision made by the great powers. Closed-door meetings began to dominate the schedules of heads of state. In Washington, the underground Situation Room of the White House became the center of sleepless nights. There, generals, NASA officials, DARPA experts, and intelligence advisors sat around a table, watching the latest data on Atlas projected onto giant screens. One question echoed again and again, pounding like a drum. If Atlas is artificial, who controls it? And who bears responsibility if it can act? The tone in these sessions was no longer purely scientific. It was now laced with suspense and political unease. A specialist briefed the room. Spectral analysis indicates Atlas may possess a uniformity of structure unprecedented in natural formation. Such consistency is something natural processes struggle to replicate. If the artificial hypothesis is confirmed, then we are looking at material engineering that far surpasses humanity's industrial capacity. The room fell silent. That statement was not just science, it was a political bomb. In Beijing, a classified report from the Military Science Commission was delivered straight to the Politburo. It read, "If Atlas is a probe, then it suggests an entity has prioritized observation of the solar system. We must consider the possibility that this is a surveillance instrument, not merely a natural phenomenon." The line sent a chill through China's leadership. In political logic, surveillance equates to power, and power equates to a loss of control. Europe, meanwhile, struggled to find unity. Smaller nations feared that the US and China would conceal any definitive information, turning Atlas into a strategic advantage. In a tense session of the European Parliament, a German member declared, "Atlas is not just a scientific question, it is a question of global equity. If it proves artificial, humanity must face it together. The truth cannot be monopolized." But almost immediately, a French delegate shot back. "And how can we trust that the US or China would ever share? We must prepare an independent course of action." The atmosphere in Brussels felt like the Cold War reborn. In Moscow, national security officials framed Atlas as a potential lever. One advisor said bluntly, "If we cannot control Atlas, we can at least turn it into a tool of pressure. Its ambiguity can be used to stoke doubts within NATO, to fracture the West." Russia knew it lacked the resources for a direct technological race, but it could weaponize suspicion, and suspicion was often enough to destabilize confidence. At the United Nations, an emergency session was called after several media outlets leaked hints that Atlas may bear artificial signatures. Delegates from across the globe gathered around the circular table, but unity quickly dissolved. An African representative argued, "If Atlas is artificial, it belongs to all humanity. No single nation can claim it." The American delegate countered with a calm but cutting phrase, "Extraordinary claims require extraordinary evidence. Until we have that evidence, no one has the right to declare anything as fact." It sounded reasonable, but in the ears of many, it was a warning. The United States would keep any proof to itself. For the public, leaks from these closed sessions only heightened the collective shiver. Citizens watched as leaders said one thing in press conferences, while classified documents hinted at something else entirely. Trust began to fray. A journalist in London wrote, "Atlas has not only exposed a gap in our scientific knowledge, it has widened the gap in our political trust. We no longer know whether our governments are protecting us or concealing the truth from us." And so, suspense and anxiety became the dominant rhythm of society. Atlas itself did nothing. It remained silent, steady, impenetrable, but that very silence drove humanity into overdrive. Secret meetings stacked upon secret meetings, classified reports piled higher each week, and the public was left to drown in doubt. Perhaps what we were truly witnessing was not just a cosmic mystery, but a global power game where truth itself had been stamped top secret. By mid-July 2027, geopolitical tensions escalated with startling speed. Atlas, once nothing more than a distant speck in the sky, had now become the center of a shadowy power race. The great powers began to act as if every dark hypothesis about it could be true, and it was precisely this proactive stance that plunged the global atmosphere into suspense and unease. In Washington, top-secret plans began to take shape, stamped with classified code names. No longer confined to spectral analysis, discussions shifted into security simulations. If Atlas can transmit signals, can we intercept them? If it is a probe, could it conceal weapons? And what defense do we have? The Pentagon started pouring emergency funds into space defense projects ideas once relegated to science fiction. From geostationary orbital radar systems to proposals for deploying laser-armed satellites, every scenario, no matter how improbable, was treated as urgent. In Beijing, the Ministry of Defense was equally ablaze with activity. Chinese generals warned, "If the US develops technology from Atlas before we do, they will secure an irreversible advantage." As a result, a series of secret programs were launched, enhancing observation satellites, running supercomputer simulations to model Atlas's material composition, and, according to some reports, even drafting a plan for an unmanned mission to intercept the object, though the chance of success was close to zero. Moscow, limited by resources, chose another path, escalating information warfare. Russian state media broadcast bold claims that Atlas might be a secret American technological project designed to intimidate the rest of the world. Though lacking evidence, these statements planted seeds of doubt in the global public, eroding trust in any data published by the West. For Russia, suspicion itself became a weapon. Europe found itself divided. France and Germany pushed for transparent cooperation, calling for global data sharing. Eastern European states, however, wary of Russian influence and America's technological dominance, quietly aligned with NATO-backed initiatives. The European Union turned into a political battleground, Should it pursue openness or secrecy, collaboration or competition? International meetings increasingly resembled tense stage plays. At a NATO conference, an American official declared bluntly, "We cannot allow Atlas to become military technology in someone else's hands." A German representative shot back, "Atlas does not belong to any one nation. It belongs to humanity." But a Polish delegate muttered under his breath, "Humanity cannot act as one country. In the end, the strong will take it." His words echoed like an omen of a new Cold War. The most chilling fact was that no one truly knew if Atlas was artificial. But uncertainty itself drove the powers to behave as if the worst-case scenario were inevitable. One international analyst called it the phantom effect. Atlas may be natural, but with just a 1% chance it is technology. 100% of the political system will treat it as a threat. On social media, the public felt the tension directly. Rumors of space weapons programs, emergency satellite launches, and midnight strategy meetings spread like wildfire. People began to fear that instead of solving the mystery of Atlas, humanity might hurl itself into a spiral of confrontation with no escape. A Tokyo newspaper summed up the mood with haunting clarity. "Atlas doesn't need to do anything. Its mere existence is enough to expose the nature of the great powers' suspicion, anxiety, and the hunger for control." The article went viral, shared millions of times, because it captured the chilling sentiment of the world. Atlas hung above, like a mirror suspended in space, reflecting every fracture in the heart of humanity. By the end of July 2027, Atlas was drifting farther away, its light fading in the telescopes, yet the shadow it cast upon Earth only grew heavier. In security briefings, a new phrase began to echo with chilling regularity: the cosmic Trojan horse. No one dared claim to know what Atlas carried within, but no one dared dismiss the possibility that it might be a container harboring technology, data, or even intentions that humanity was not prepared to confront. The idea sounded like science fiction, but it crept into classified reports and then seeped into the press. An American defense analyst wrote, "If Atlas is natural, we will breathe easy. But if it is not entirely natural, then its silence is the perfect disguise. It lulls humanity into lowering its guard, while masking itself as a quiet message from another intelligence." The article went viral, shared millions of times, because it touched a nerve. Silence can be more terrifying than words. At international conferences, suspense became the prevailing atmosphere. A United Nations delegate exclaimed, "Atlas is like a stranger knocking at our door, then standing silently outside. We cannot tell whether he brings a gift or a weapon." The image sent shivers through the chamber. Social psychologists explained that Atlas's silence was precisely what triggered humanity's darkest imagination. When faced with incomplete data, the human brain instinctively fills the void with worst-case scenarios. And now, the entire global political system was reacting accordingly. The United States accelerated the launches of new surveillance satellites. China unveiled plans for a third-generation space radar network. Russia ramped up propaganda, planting doubt into every Western report. The European Union quarreled endlessly about whether to join the arms race or attempt the role of mediator. On the surface, these were strategic choices. Beneath them, they all sprang from the same undercurrent of unease: the suspicion that Atlas might embody alien technology, and that whoever unlocked its secret could reshape the entire order of the world. Among the public, quiet fear seeped deeper. People whispered, "If Atlas is a Trojan horse, has it already released something we cannot yet see?" A popular blogger wrote, "The terrifying part isn't Atlas drawing near. The terrifying part is Atlas passing by, leaving us in eternal doubt." The post spread like a modern-day curse, making millions feel as though they were trapped in a cosmic courtroom where humanity stood both as witness and as potential defendant. And within this turmoil, one truth became starkly visible: political borders meant little against the silence of the cosmos. Whether the US, China, Russia, or Europe argued endlessly, Atlas floated on, indifferent to the flags flying on Earth. Its silence was a reminder that boundaries, wars, and schemes exist only in the human mind. The universe does not recognize them. As Atlas slipped further beyond reach, humanity received no answers. Instead, it left behind a collective scar, a suspense unlike any before, the shiver of knowing we had glimpsed something beyond comprehension, and the gnawing fear that its secret might be buried forever within the classified files of the superpowers. By the end of 2027, the night sky had returned to normal, at least to the naked eye. Atlas had drifted beyond the reach of civilian telescopes, reduced to nothing more than a faint smear in the data from the world's largest observatories. And yet, it was precisely at the moment of disappearance that the world was swept into a wave of astonishment, tinged with reflection. What overwhelmed humanity was not its presence, but its absence. The silence of the cosmos now thundered louder than any signal. Inside research institutes, as the screens that once glowed with Atlas's anomalous data went dark, scientists fell into quiet. They had grown accustomed to those strange numbers, those curves that mocked natural law, those spectra that denied intuition. Now, with nothing left to record, a hollow feeling spread. A Harvard researcher wrote, "Atlas has departed, but the emptiness it leaves is the most important data point of all. We do not know more, but we are no longer the same." For the public, its vanishing brought not relief, but shock. On social media, millions shared pictures of an ordinary night sky captioned, "We grew used to mystery. Now, normal feels strange." Many confessed they could no longer look at the stars the same way. Something irreversible had shifted. Every point of light, every streak across the heavens, became a reminder of Atlas's brief but searing presence. Observers compared the feeling to humanity's collective moment in 1968, when Apollo 8 captured the famous Earthrise photo. That single image had reframed humanity's self-understanding, small, fragile, yet united. Now, Atlas had done something similar, but on a broader scale. It underscored that even when we think we understand the universe, vast voids remain unnamed and unknowable. In classrooms, teachers retold the Atlas story not as a sterile fact, but as a metaphor for knowledge itself. A teacher in Brazil told her students, "Atlas taught us that silence can be a message. When a single object can expose cracks in our understanding, its disappearance is itself a lesson in the limits of our vision." The students listened in stillness, sensing not fear but awe. The cosmos could teach through presence and through absence alike. Among artists, that same awe transformed into creation. A composer in Vienna premiered a symphony called The Silent Comet, opening with blazing crescendos that gradually dissolved into a long, drawn-out silence. A Japanese painter exhibited a series called Shadows of Atlas, each canvas dominated by dark voids between strokes of light, as if to insist that absence was Atlas's true form. These works sought not to explain, but to still their audiences, to leave them caught between wonder and contemplation. In families, the tale was passed down as a kind of modern myth. Parents told their children, "There was a time when the whole world looked up at one bright speck, and every definition trembled." The story carried emotion more than data. It was not just about remembering Atlas, it was about remembering the collective realization that humanity is not all-knowing. What lingered, strangely, was a kind of sweet doubt. No one could say for certain what Atlas had been, natural or artificial, celestial body or technological construct, but it was precisely this ambiguity that kept it alive in the imagination. An Italian novelist wrote, "Had we known what Atlas was, it would have become just another entry in the encyclopedia. Because we do not know, it has become the opening chapter of an endless book." The conclusion of Atlas's disappearance was not a period, but an ellipsis. It left a void, and that void reverberated across science, art, and the human spirit. Humanity marveled not only at what had been seen, but at what would never be seen again. And in that silence, reflection deepened. Perhaps it is the very things we cannot grasp that keep humanity's journey of discovery alive forever. After Atlas slipped beyond sight, something strange happened. It did not fade into silence, but erupted into culture. Scientists grew quiet in the absence of new data, but the creative world found its voice in other languages, music, painting, literature, and cinema. Atlas quickly became a collective symbol, sparking inspiration even in those who had never cared about astronomy. In New York, a documentary titled Silent Visitor premiered before thousands of viewers. The film did not attempt to explain what Atlas was, it simply traced humanity's journey of watching it, from the moment of discovery to its final disappearance into darkness. Audiences left the theater with reddened eyes, not from fear, but from the feeling that they had just witnessed a chapter of history that transcended politics and science alike, a chapter about existence itself. Critics hailed it as a collective diary of humanity, written in the light of a strange celestial body. We know not take cerd for repaces. Music, too, joined in. A young band in Seoul released an album called Atlas Dreams, where each track served as a metaphor: orbit of doubt, silent flame, and the vanishing. Their sound echoed with blended emotions: wonder, skepticism, and yet hope. The album quickly climbed global charts, proof that Atlas had leapt from science into the fabric of popular feeling. Literature followed in a flood of novels and short stories inspired by Atlas. A Mexican author wrote, "The Comet That Watched Us," imagining a world where Atlas was a cosmic eye, forcing humanity to live authentically because every act was being observed. In France, another novelist penned Atlas, Le Silence, portraying a society where the object's silence evolved into a new religion, teaching people to seek meaning in emptiness rather than in answers. Visual art and installations also exploded. In Berlin, an artist built a massive structure called Vacuum of Meaning, a cavernous empty hall, lit only by a single small point of light suspended in darkness. Visitors stood before it, overcome by the same loneliness and awe they felt gazing at Atlas. In São Paulo, a group of art students staged an outdoor exhibit. Hundreds of small mirrors scattered across a plaza, each reflecting the night sky, suggesting that Atlas now lived only in the gaze of each observer. The cultural impact was not confined to high art. In daily life, Atlas became an everyday symbol. T-shirts printed with a glowing speck and the words, "Remember 2027" sold worldwide. Graffiti in Tokyo and Los Angeles depicted Atlas as a radiant eye gazing down on the city. Even tech companies rushed to capitalize. One software giant released a new operating system called Atlas OS, marketed with the slogan, "Silent but powerful." What stood out was that Atlas was not used merely as decoration. It became a living metaphor across many fields. Environmental activists framed it as a reminder of the limits humanity has yet to see. Psychologists described it as a collective obsession, proof that people need a symbol to reflect their anxieties and hopes. Even theologians joined the chorus, interpreting Atlas as a sign of humility, a reminder that God, or the universe itself, still holds countless mysteries unrevealed. The remarkable thing was that, although each group interpreted it differently, all found in Atlas the same raw material, the feeling of astonishment fused with contemplation. It did not impose a single message. Instead, it opened infinite paths. And it was precisely this multivalence that allowed Atlas to root so deeply in culture. Thus, instead of fading after its disappearance, Atlas became more present than ever in the human imagination. It had transformed into a timeless symbol, not one bound to an answer, but to the enduring power of a question. After the waves of culture and art, Atlas began to seep into a deeper layer, the philosophy of life and human reflection. Not only scientists, not only artists, but ordinary people too, felt compelled to pause and ask themselves, if a single object can shake every definition we rely on, then where do we truly stand in the universe? There's 18 night to self, and then 18 no crows. In universities, philosophy departments hosted non-stop seminars with stark, electrifying titles. Atlas and ontology. Discussions turned on a haunting question. Perhaps every definition of existence is only provisional. If a comet can behave as though it were not a comet, then could reality contain forms of being beyond the reach of our language? A professor at Oxford declared, "Atlas is a slap to the pride of knowledge. It reminds us that our language may be beautiful, but beauty does not guarantee truth." Existential philosophers also joined the conversation. They saw Atlas as proof of the absurdity. Albert Camus once described, "The universe has no obligation to align with human expectations." Yet instead of despair, many found in Atlas an oddly luminous source of hope. For if the cosmos can reveal a paradox as strange as this, then surely it must hold countless possibilities we cannot yet imagine. As one French philosopher wrote, "Atlas does not close the door of understanding. It opens thousands of new ones." Religion, too, adapted its interpretations. Some took Atlas as evidence of the intervention of a higher intelligence, but many theologians urged caution, framing it instead as a gift of humility, a reminder that despite humanity's advances in technology, we have only skimmed the thin surface of the universe. A priest in Rome, during his sermon, said, "Atlas is not here to make us tremble, but to remind us that whether in belief or unbelief, in science or faith, we all stand before the same truth." We are small, and we need each other. Alongside hope and inspiration, deep skepticism persisted. Many asked, was Atlas nothing more than a collective illusion? Have we inflated a mere astronomical event into something metaphysical? This doubt, far from extinguishing reflection, made it more alive. It was within the tension between faith and doubt that people discovered a new kind of maturity. Atlas offered no answers. It forced humanity to dwell in the grey zone, where conviction and uncertainty coexisted. And strangely enough, that liminal state itself became a source of motivation. Many young people began to see Atlas as a symbol of uncertainty, and they drew strength from it. Across online forums, the phrase "embrace the unknown" spread like a mantra. It expanded beyond the context of Atlas, becoming a life philosophy. Daring to step into uncertainty, daring to start new ventures, daring to change, daring to love even without guarantees. Sociologists noted that Atlas had sparked a wave of collective humility. After decades of global confidence in technology, artificial intelligence, and space exploration, a silent object suddenly reminded humanity that truth is still vaster than imagination. This sense of awe mixed with contemplation did not paralyze people. Instead, it helped them find balance, doubting themselves, yet hopeful for the journey shared. A Japanese philosopher summarized it at an international conference. Atlas is not merely an astronomical story, it is a spiritual mirror. It shows us that the human ego longs to control, but reality cannot be caged. And in that very powerlessness, we learn humility and we find inspiration to keep searching. And so, as humanity gazed into an empty sky, they discovered a beautiful paradox. It was the absence of Atlas that made them more deeply present to themselves. Astonishment, reflection, hope, and doubt blended into one, opening a new era. An era where truth was no longer only about answers, but about the shared journey of questions. As the year 2027 came to a close, telescopes turned toward new targets, and breaking news cycles shifted to fresher crises. Yet in the human mind, Atlas remained. No longer just a faint speck in the sky, it had become a living metaphor, a collective memory not easily erased. And in that stillness, humanity entered a phase of profound reflection, not around the question of what Atlas was, but who we are when faced with such a mystery. In many circles, historians began to label 2027 as the year of silence. Not because there was no noise, but because the silence of Atlas had drowned out every other sound. It forced the world to pause, to stare directly into its own limitations. At the year's final international summits, the agendas were not only about technology or security. Entire sessions were dedicated to a single question: what have we learned from Atlas? One report concluded bluntly, Atlas did not alter the physical structure of Earth, but it permanently altered the mental structure of humanity. Awe tinged with contemplation remained the dominant emotion. Philosophers compared Atlas to humanity's axial moments, times when civilization was compelled to see the cosmos with new eyes, just as Copernicus dethroned Earth from the center, or the Earthrise photograph revealed the fragility of our blue planet. Atlas had opened a new axis of perception. It showed not only that humans are small within the universe, but also small within the limits of our own knowledge. That realization made many shudder, yet also stirred inspiration. If there is so much we do not know, then there is still so much left to discover. From that awe arose hope. Hope that Atlas was only the beginning, that future generations, armed with stronger technology, might one day reach deeper into the cosmos's mysteries. A young scientist in India wrote, Atlas was an invitation. It came and went, but it left a door ajar. Our task is to step through that door. The words went viral, transforming into a rallying cry for new space research movements. Yet alongside hope, skepticism thrived. Many continued to ask, are we projecting too much onto Atlas? Are we burdening it with meanings it never held? But paradoxically, that very skepticism kept the memory alive. The more people doubted, the less they could dismiss. Doubt became fuel, ensuring the fire of inquiry never went out. In popular culture, Atlas solidified as a symbol of collective maturity. Science magazines wrote, Atlas explained nothing, yet made humanity agree on one truth. Knowledge is never complete. Sociologists dubbed it the consensus of doubt, a rare state when the entire globe, despite differences of politics, religion, or culture, shared one common experience: to stand together before the incomprehensible, united in astonishment. The final tone Atlas left behind was philosophical. It reminded humanity that sometimes the question matters more than the answer. It taught that silence can echo louder than any explanation. It showed that even when we lack control, we still retain the right to reflect. And in reflection, people found renewed strength, the strength of hope, creativity, and courage to keep journeying into the infinite cosmos. Looking back, many scholars concluded, Atlas was not merely an astronomical event, but a rite of passage for humanity. Like a child who must face fear to grow, humanity had to face a paradox to learn humility. And in that humility, we uncovered new power, the will to dream, the resilience to create, and the courage to keep searching. Ultimately, what Atlas left behind was not data, but an open question. How will you live, knowing there are truths you may never fully understand? That question reverberated through classrooms, laboratories, and the dreams of young people staring up at the night sky. And perhaps that is Atlas's greatest legacy, transforming silence into an endless source of inspiration, so that humanity may continue to search, to hope, and to marvel at the vastness of the universe.